have any questions throughout the event, you can go ahead and direct them to the Q&A box at the bottom of your screen. And the last reminder before I go ahead and kick it off to Barbara to get started is that if you are not already an IFT member and you are inspired by this webinar and want all of these benefits listed on the screen here, go ahead and scan the QR code at the bottom right hand of your screen or visit ift.org/membership. And then I am going to head and stop share and kick it off to Barbara.
Well, good morning, good afternoon, good evening, wherever you are in the world. I'm Barbara Lyle. I am a senior consulting advisor to IFNS, the Institute for the Advancement of Food and Nutrition Sciences, and moderator for this 4-hour webinar. I have over 25 years of experience working at the intersection of translating nutrition into decisions that product technologists, product developers, people in regulatory and scientific affairs are having to translate in taking foods and ingredients and making them into products that consumers can buy and eat. And I will bring that to bear in how we moderate the questions that come in, elaborating and framing them up in ways that I know that many of you have had to ask and continue to have to ask. So this webinar includes several nutrition experts. So we are nutrition people working to translate what we know about nutrition and what we're learning about nutrition into information about fiber and non-digestible carbohydrates that can be useful to product developers and others working in the food industry. We have to make decisions not only about how the fiber functions in the food, but also whether or not it delivers the health benefits that are intended and whether it allows the ingredient being used to be labeled as fiber. So first, I want to thank our two sponsors, IFT and also IFNS, for planning and for much of the work that you will also see presented by some of our experts. For anyone who doesn't know about the Institute for the Advancement of Food and Nutrition Sciences, or what we call IFNS, we are a tripartite of government, industry, and academia, experts that work collaboratively to advance public health. And I have put on the slides the website as well as a specific contact person, the executive director at IFNS, and you are very welcome to reach out to either Wendelin at IFNS or take a look at the website. So this particular webinar was planned with the Carbohydrate Committee at IFNS along with some of the working groups at IFT, and thank you to those who have helped with that. So overall, our objective today is to translate human nutrition efficacy research, current and emerging, about fiber and blends in order to fully realize the potential human health benefits of foods that are formulated with fiber. Some of the more specifics are shown on the slide. My disclosures for the past 3 years are shown on this slide, including scientific advisory boards. I do run my own consulting company. I work for 2 universities, and I have received consulting fees from the organizations listed. Our agenda for today is we're going to start off with Joanne Slavin on why more fiber should be formulated into foods. We're going to go with Paula Trumbo next on food labeling for dietary fibers. We're going to next touch on the emerging research about dietary fiber innovations. Then we're going to offer 2 practical tools, one a database and a second is information that Hannah Holscher's group has put together on tolerability. What I'm going to ask you to do for your questions is to post them in the questions section of the webinar. Anything that's really specific to clarifying what a speaker has talked about specifically, we will handle after that speaker. And anything that can be broadened, framed up, answered by more people, we'll just automatically move to the panel discussion at the end. So sometimes it's really interesting to hear not only what a person who's done a lot of work in regulatory thinks, as well as the person who's worked on clinical trials. So that's where most of your questions will probably be answered, is in the final section of the panel. The last thing I wanted to just mention is that we are running this webinar without breaks so that you can take your own breaks at times that make sense for you. I personally have my coffee, my apple, and a snack bar. So I will be here the whole time, but please do what makes sense for you in terms of taking breaks. And with that, I'm going to turn it over to our first speaker, Joanne Slavin. We cannot hear you, Joanne.
I am here and I am going to screen share. So thank you, Barbara. That's what I'm working on. You don't see anything, right?
That's correct. We see you.
I know. All righty. How about now?
We do not see your slides. We see something that says Zoom. Maybe you're sharing your screen instead of the slides.
I see my slides here, but I guess that's not working for you.
Maybe just stop screen share and try again. Make sure you select slides.
Okay.
Sydney is a backup. Maybe get her slides open just in case. Oh, there we go. See him now.
Are we good?
Yep, we do. Thank you.
You bet. Wonderful. Thanks so much for the sponsors for putting this together. Really practical information on how to get fiber into foods. So I'm going to introduce myself. We get to introduce myself. I have spent 40 plus years trying to get people to eat more fiber. I'm a dietitian. I'm also a professor in the College of Food, Agriculture, and Natural Resource Sciences, University of Minnesota, Twin Cities. It's tough. And the nice thing about fiber is it's something we want people to do. It's a positive nutrient, so there's huge opportunities. I was a panel member in 2001 and worked with Dr. Trumbo, where we put together proposed definitions for fiber. Also was a member of the 2010 Dietary Guidelines Committee, where we again identified fiber as a nutrient of concern. So lots of work to do. These are my disclosures. As you'll notice, I kind of work for a lot of people. I'm really fortunate to have got some good grant support for my research. Also serve as a scientific advisory board on a kind of wide group of people that you think, hey, this person has no core, but I'm totally committed to getting more fiber into food. So anybody that's on that team, I'm happy to join. Grew up on a farm in Walworth, Wisconsin, a former dairy farm that I now am the owner of. So I am the owner of a farm, very interested in sustainable agriculture and making agriculture profitable. I work for the University of Minnesota and do a lot of consulting and appreciate people wanting to work with me. So I get the fun topic of the overview of fiber and why you're committed and why you're on this seminar. So dietary fiber and health, the gap, which for its sources matter. So kind of trying to define definitions, challenges of adding fiber to foods, and then some of these blends, cost, some of the more practical things. And then just, I'm totally committed to, we have fortified other nutrients to improve the food supply that we should be there and getting more fiber into our food supply. So first, definitions. It's like, oh, why is it so hard? And why does it take so long? Because it's different. Dietary fiber is non-digestible carbohydrates and lignin that are intrinsic and intact in plants. And that was a tough definition. Paula can tell you how hard it was to get there. But we know that when people eat fiber, plant foods, that there are some health benefits. They're intrinsic and intact in plants. I think it's a good definition of, we basically give fiber a pass. When you eat it in foods, we know it has health benefits. So the next category are functional or added fibers, isolated non-digestible carbohydrates with beneficial physiological effects in humans. This definition was put together more than 20 years ago, that for us to feel good about these added fibers or functional fibers, they need to have a beneficial physiological effect. And this really hasn't been acted on until 2016. It was actually put into regulatory that functional fibers have to have supporting clinical evidence in human subjects that it provides a beneficial physiological effect. And we'll get more into those definitions. Definitions of fiber have evolved over time, but traditionally it's resistant polysaccharides with a degree of polymerization greater than 10. But this is varied all over the place and varies across countries and is really frustrating for people that are in regulatory and have to put labels on things. So now most countries say, hey, if you are an oligosaccharide between 3 and 9 and function as dietary fiber, you're not digestible. We should allow you to be fiber, but there are differences there that we will get into too. I think what's happened is fiber is a chemistry experiment. So I started measuring fiber in foods. And this is where on a label, we need to be able to measure how much fiber is in a food and put that on a label. As we move to this more physiological definition, we have new changes to get around. So if you go back, chemical definitions, crude fiber, including cellulose, hemicellulose, lignins, gums, mucilages, oligosaccharides, pectins, and other substances that associate with fiber and getting to measure those. And then in the 80s, if you go back, as we kind of tried to simplify it and say, hey, soluble fiber lowers cholesterol, insoluble fiber increases stool weight, there was a big emphasis on insoluble versus soluble. And those kind of help us a little bit, but they really create more challenges than they really solve. And so now we have official methods from the Association of Official Analytical Chemists to measure total dietary fiber, soluble fiber, and insoluble dietary fiber. And if you go back in the US, you could be listed as dietary fiber if you were captured by an official AOAC fiber method. So getting the references I give you there will give you a lot about the discussion of this moving forward and the methods that are out there. I want to go back to just say, why do we care? Because fiber is a marker of a healthy diet. Generally, we're taking things out of the diet and saying, hey, get rid of added sugars, get rid of solid fats, but fiber we want you to get more of. What is it in? Whole grains, fruits, vegetables, legumes, nuts, and seeds. So recommended foods are higher in dietary fiber. But it's a physiological concept, which makes it really hard to think about as traditional nutrition people like to think. Carbohydrates and lignin and escape digestion in the upper GI tract that may be fermented in the gut. So how do we measure that in a human? It's really difficult. I have argued this on many panels, but I consider it a nutrient in the 2002 dietary reference intakes. It is part of it. It's a nutrient of concern in dietary guidelines, and our usual intake is only about half recommended levels, which we will bring back again and again today. It's regulated, 28 grams of the daily value on the nutrition facts panel. And so it's information front and center for consumers. We do have health claims in the US already that are pre-existing some of this regulatory. So we know oat bran, barley, and psyllium have a role in reducing cardiovascular disease risk. So really going back in my history, most foods are not very high in fiber. So people think, hey, lettuce, it's full of fiber. Just no, they're like 1 gram in lettuce, big deal. So most of the foods we consume don't have much fiber. Standard servings of fruits and vegetables contain 1 to 3 grams of fiber. Figure you got to get to 28. That's a heavy lift to get there. How do I cheat and get there sooner? I take in some higher fiber things that have added fiber in them already. So some of the cereals that are out there up to 13 grams a serving, that gets me out of the starting gate better than most things are going to get to me. That help me out. But I can add functional fibers, added fibers to foods and beverages, but there are lots of challenges. The things aren't soluble, they taste terrible, they cost a lot of money, there's regulatory challenges. So it's not as simple as just, hey, throw it in, buddies, let's get it done. Also, fiber comes from other sources. So we have over-the-counter laxatives, fiber supplements that are out there. So putting that together is important too. I like to use this slide that I use in my teaching that if we think about it, you eat this diet, and most of the macronutrients they're digested, absorbed, and get into the human host. So you eat some sugars, you eat some carbohydrates, those get broken down, they get absorbed, and then the body's going to deal with those. On the other side is fiber, which is undigested food components, mostly carbohydrate. What happens to them? They go all the way through the small intestine till they get to the large intestine and then can be fermented by the intestinal microbiota. What happens then is we can get production of interesting compounds. Short chain fatty acids give us energy, also have some interesting physiological effects. Vitamins, those that go into the human host. The human host is making things like mucus, carbohydrates that the microbiota can actually work on. So we're never in a steady state where it's easy to measure this. Things are always happening. This is also from Fiber, most of the actions in the large intestine. I just told you, you got to survive to the large intestine before you actually can be called fiber. But fiber does so much along the whole digestive GI tract that's really important. Increased chewing, more saliva production, increased gastric detention, delayed emptying, slowing down nutrient absorption, glucose, insulin responses affected by fibers, changes in gut hormones. Really interesting topic right now. Fiber has been shown to do those things too. Once we get to the large intestine, short chain fatty acid production, microbiota changes, changes in pH, all that have health effects throughout the body. So where do we come up with our fiber recommendation? This is frustrating to people because everybody's like, well, there must be a ton of studies that show you have to eat this much fiber, stool weight goes up this much, and voila, there's the number. But actually it's not. What we have, it's an epidemiological model of looking at intake of fiber in 4 large cohort prospective studies and risk of cardiovascular disease. So in these studies, we follow people over time. We know how much fiber they consume, and then we can look at the risk of getting a disease or dying from a disease and model it from there. So in these studies, if you look at dietary fiber intake, what we find is that when we put all these studies together, you get a really reduced risk with fiber intake. So it's very significant. It's a really strong signal. And this is really where we came up with the adequate intake for dietary fiber. So it is 14 grams per 1,000 calories. That's how you come up with the 28 grams. And this is a really good, strong number, and it's a good place, and we're half the way there. So I think that is where that number comes from. What's happened, though, too, as we've moved along, is that what things count as fiber. So I mentioned that generally the older fiber methods did not capture oligosaccharides and resistant starch. So we know that some of these compounds are really interesting. Oligosaccharides are our best prebiotic fibers. Resistant starch has shown data that it is more likely to increase levels of butyrate, but the official methods didn't get this. So if you watch the history, and this is really well described in the Barry McCleary article that I've referenced here, we have come up with these other methods to capture this. But a lot of what the databases for dietary fiber have not been updated. So what we know is total fiber is required on the nutrition facts. So that's required. You can put soluble and insoluble. They are voluntary on the nutrition facts. But this idea that soluble is better than insoluble, which I think a lot of people believe, is really not true. Even in that 2001 report, it was stated solubility of fiber does not predict its effects. So other things, where do we move to other things? Viscosity. We know things like oat bran, barley bran, psyllium are very viscous fibers that do lower serum cholesterol and typically have more of an effect on blood glucose. But where do we care about viscosity? Is it in the stomach? Is it in the small intestine? We don't know that. So we know it's important, but we can't really put that on the label. Fermentation. Yeah, we want to know how much of that fiber gets broken down, but how do we study that in vivo? We don't have that information. Physical structure is really important. We know that a whole food, when you grind it up, it's going to have different effects. How is it associated? Proteins that are associated with a particle size. We have some data on that. Can't really get into that in a, beyond the total amount. Also, plant foods contain fiber, but maybe fiber is just a marker. Maybe it's the vitamins, minerals, and other phytochemicals that really are the game changers. So Paula's going to go into this in great detail, but what I really appreciate that FDA got involved and said, hey, consumers were getting really suspect about fiber, these fake fibers that do anything. And they're like, no, wait a second. We're going to actually do a scientifically based review of this topic. And you now must prove through published clinical studies in human subjects that you have a beneficial physiological effect. And they came out of the box with the first ones that she'll talk about in much more detail. But just remember that this new dietary fiber regulations, each isolated and synthetic fiber has to have a proven health effect. If I'm an intrinsic and intact fiber, I don't need to show that to be listed as fiber. The qualifying health benefits are very broad because fiber does lots of things. So they don't really box you in on this. You do need to have some clinical studies to prove that you have a beneficial physiological effects. And in the US, changes in the gut microbiota are not considered a health benefit. They're considered a mechanism. And you will see differences across countries that will be talked about later in this seminar. These were the first ones that came out with, they already had data, and I was very happy. The cellulose study that they used was a study I did back when I was in Madison, and feeding people fiber and collecting fecal samples is not work that most people want. These are ones that have come in since then, and so they are always reviewing topics and saying which of the fibers have a physiological benefit. Paula will talk more about some of the benefits that are there, but it's quite broad that any physiological benefit will allow you to prove that you have a physiological benefit. I wanted to go back to the fiber methods because I also spent a lot of time on this, and it's still a huge problem. That this is just a Venn diagram of how hard it is to measure this really diverse group of carbohydrates that aren't digestible. So total dietary fiber, these standard methods are the ones, and I really appreciate the testing organizations that do dietary fiber measurements. It's very expensive, it's very difficult, and trying to get our databases up to date. Just a little thing out of our lab I wanted to bring out. Just white pasta. We think that what are the biggest fiber sources for kids? And it's usually French fries and white bread. It's like, well, they don't have that much fiber, but they do have some fiber. And this was with the new fiber methods that capture all of these other components, especially resistant starches. The old label for pasta, any type of pasta, 2 grams per serving. But when we actually sent it out to a couple of standard labs, we got 3. Seems like nothing, but if we want to look at food intake and fiber intake in kids, it's a huge difference. It's a huge difference. So getting that new data up and running is very important. So what is this implications? Our nutrient databases need to be updated. USDA is very busy on that. It's really tough. And most of our older methods, they're not wrong. It's just, are we double counting or are we forgetting different values? And food manufacturers, you have to go out and get this information to make sure you're on your label, but you also have to make sure that your isolated fiber has a physiological benefit. But the nice thing is we have a lot to do here. So generally, if you're using these newer methods, you may get higher values, which are not wrong. They are actually true. I mentioned this solubility thing. I believe we need to move off of solubility just because it isn't, but consumers are still looking for it. It's still on the nutrition facts. So it's not like dead, but it doesn't really predict its physiological effects. Some of the other things that you're going to hear more about in the seminar are other physiological effects, fermentability, viscosity, but these are things that we're doing in mechanistic studies rather than clinical studies. Remember, total required on nutrition facts, soluble and insoluble, voluntary. I had to get here, and this is my life. Why don't we have more data on fecal samples? If you've never done these studies, I think you understand. We don't have anything on epidemiological studies. So when we go back to how we got our recommendations for fiber, those were blood levels. Those are these large studies, which typically haven't had fecal samples. That is changing. More studies are trying to collect fecal samples and get some data on fecal samples. But what are we looking for? What's the right thing? Stool weight, stool chemistry, microbiota, microflora, stool frequency, that one's easy to collect. And now you see a lot of quality of life. And you'll hear more from Dr. Holscher later on, trying to come up with new methods to answer these questions that are really important. So come check out our stool samples. Even IKEA understands how important it is, and people do it. I mean, they care about it greatly, but as far as coming up with fiber recommendations based on this, pretty hard. So these are the kinds of studies. Look and cook or look and tell me. The King's stool chart here, you'll hear more about the Bristol when you hear from Dr. Holscher today. I want to just bring this in. We did some initial studies on inulin, and inulin doesn't increase stool weight, which you wouldn't expect because it mostly gets broken down. So if there's lots of fermentation, nothing survives until you get a fecal sample. How much would you expect? You're going to get some increase, but you're not going to get as much increase as something like wheat bran that does survive till the end of the run and bring a lot of water along with it. And I just wanted to mention this. Fermentation really varies greatly. Pectin inulin are probably 90 or 100% fermented, or purified cellulose less than 10%. So most of it survives, and therefore it does increase stool weight. But it's not just, that's not all that's going on. When fibers are fermented, other things happen. So this biomass, bacterial mass, does increase fecal weight too. And feces are usually 75% water. So any surviving fiber or bacteria is going to increase the weight. This was one of my wonderful students talking about digestive health and what are people looking for? Absence of digestive disease, you bet. Normal bowel function, quite subjective. What's normal? If you can't get normal in this, you're not going to get normal in anything. 3 per day or 3 per week is considered normal by GI docs. So bowel movements, bowel frequency doesn't really help us as putting healthy versus non-healthy. There's some data that over 200 grams per day, people that go and measure, and there are some ways of doing that fairly simply, I heard, but people say that's diarrhea, but vegetarians eat tons of fiber, have very large stool weights, and people don't want symptoms, right? So that Dr. Holscher is going to talk a lot more about that, and quality of life suffers when gut health is compromised. I wanted to get to this point because really have somebody who's lived in the fecal world for a really long time. Nobody seemed to care. And then this research came out that really was a game changer. No, it's a very small study moving from stool weight to the gut microbiota and a link to obesity. 2006 study, 12 unrelated obese subjects on fat and carbohydrate restricted diets for a year. And you see a change in a gut bacteria that correlated with the change in weight. It's like, hey, this is the answer to our dreams. Let's go after the gut microbiota. People have been chasing it ever since, and we've been doing that for a long time. But what have we found? And this is a frustrating thing, I think, as people are like, hey, this is the holy grail. But most of the studies that are out there, does fiber alter the gut microbiota? So this was a meta-analysis that was published recently, 64 studies. They found that bifido and lactobacillus, as well as fecal butyrate, was higher with higher fiber intakes. Fructans and galacto-oligosaccharides led to greater abundance of both bifido and lactobacillus compared to control, which makes a ton of sense if you know anything about prebiotics. But what they didn't find is there were no differences between fiber intervention and comparators for diversity, which people were expecting, and then abundance of other pre-specified bacteria or other short-chain fatty acids. So it really was a summary of what do we know about prebiotic fiber rather than what do we know about fiber changing the gut microbiota. These are the properties that are important. We've already mentioned that, but there is no accepted definition or amount of soluble and insoluble. So I would not worry about that as much as people seem to worry about it. Just properties of fiber. Viscous are most likely to be effective, but they're impossible to put into food. So that's a problem. Fermentation, this idea of short-chain fatty acids, important. The different short-chain fatty acids, a lot of interest there. But the thing that's really probably the most interesting is that it does increase mineral absorption. So some of the prebiotic fibers, the way they got accepted as a fiber was that they increased calcium absorption. So pretty interesting. So, and then this idea of fermentation speed, rather. So if you get fermented right away, you may cause more intestinal gas. And Dr. Holscher will follow up on that. Just wanted, this is a recent meta-analysis trying to pull all this information together, which is always useful, but fiber fortified foods. So let's look at fiber fortified foods and see if they are going to predict anthropometric measures or cardiometabolic, putting all this information together. What did they find? Well, it's really significant, and it's happened. We found it for a long time. Fiber fortified food reduces body weight, fat mass, total cholesterol, LDL cholesterol, triglycerides, fasting glucose, and A1C. Wow, that's pretty impressive. But did soluble fiber really lead out of the box? It had more of a role in triglycerides and insulin, while insoluble fiber actually had more of a role in body weight, BMI, and A1C. I think that's weird, and this is always frustrating in nutrition, is that the smaller amounts had more health benefits than the larger amount. And this is just a cut point, so I don't know how important this is, but even less than 15 grams per day induced important health outcome benefits. And they included fortifying can improve these outcomes. I want to finish up on this. This is a review paper I was involved in, and just to tell you that fiber is not a magic pill, but it's actually kind of important, and it may be just a marker of a plant-based diet, and there are other things going on, but there are both short-term benefits and long-term benefits that you will see. So up here, and I like the middle here where you see short and long-term benefits of fiber within and beyond the gut. And this is important. A lot of the action's in the gut, but a lot of the benefits are outside of it. So immune system for sure, increasing mineral absorption, you'll hear more about with increasing calcium absorption. And autoimmune disease, I don't know, that might be a bit of a stretch. I always hate to get into these groups and start voting on these things, but I think that for sure there's some immune effects that are quite interesting in the prebiotic world. long-term benefits in reducing risk of NCDs and reducing constipation and other bowel conditions. Pretty much settled science. We know that fiber helps as far as bowel conditions. So why not do it? Why haven't we done it? This is a frustrating thing. We are at 28 grams of fiber and usual intakes 14, 15, 16, depending on who you're looking at. They have not changed in 40 plus years of me talking to people like you and saying, hey, let's carry the flag for fiber. So why hasn't it happened? I mean, come on, let's get it done. Why hasn't it happened? Intestinal gas production. Number one, people like, as soon as I tried that fiber, I farted and lost all my friends, and I'm not going to do it anymore. And people, the dietitians will say, hey, stick with it. Take some more fluids. It's not that big a deal. It's like, if people have a bad experience with a fiber, they're just going to move on. So you do want people that like your product because it has fiber and they don't have these negative effects. People thought that fibers only were if you had any illness, you had to get rid of them. Well, we're off of that. And that we thought that they would limit nutrient intake. So some of the old things that decreasing mineral absorption, but the novel fibers that are used in today's formulas actually improve it. And the point here is that 28 grams is useful for everybody. This is the number we want to give people. So there's a lot of space to figure out how to get that done. So why haven't anybody done it? So this is most intact and intrinsic fibers, grains, vegetables, fruits, pulses. They're not functional. I can't get them in a product. They're gummy. They're gross. I can't. People, they turn the colors wrong. They have lots of challenging. As a food developer, they're non-starters, so they're not water soluble. Can't get them in a drink. They're not stable in pH and temperature. They taste bad. They're grainy. Blah blah blah. These are all serious problems. So okay, there's one we got to get past. Regulations say I have to be accepted as a dietary fiber, or don't even start formulating with something that hasn't passed that. Clean label demands. Consumers want things that sound like real food, not chemicals. So a lot of the fibers that are out there sound really chemical. And then cost. I was supposed to cover cost. Worked really hard in getting cost information, but some of the functional fibers that have the most research are quite expensive. They may have exclusive arrangements with different companies. But to me, if you can use functional fibers to lower added sugars, be fat replacers, they may have some other benefits that can justify the cost, but the cost is something that's real. So if you're going to add fiber and it's incredibly expensive and consumers aren't willing to pay for it, it's a real thing. Just remember that fiber has to be already something that has been approved by FDA. All right, takeaways. Nutrient of concern is a huge open door. We need to double our fiber intake. Show me a way. And it's right there in front of us. I don't know why we can't act on it. So it's half levels. There's lots of space there. There's no UL for fiber in the dietary reference intake. So if you go back, the dietary reference intakes, RDAs, adequate intakes. We have an adequate intake for fiber, but there isn't a UL that says, hey, don't eat any fiber above this level. Obviously, that's not the problem we have. Vegans, if you eat all plant-based diets, you can get it up to 75 grams a day without incident. So isolated fibers to me are the best solution to get fiber in the diet without calories, but whole foods, clean label, ultra-processed foods are all issues kind of driving it the wrong way. And I believe as fiber intakes continue to be low, new interest in adding fiber to snack foods, desserts, beverages, where as a dietitian, it's like, oh, I don't like that answer. But as a practical person that wants to get fiber in the diet, I got to go there. And I'm joining that team. So I already talked about this. There are some differences I wanted to point out. Fructooligosaccharides are probably less well tolerated. There's some studies on resistant starch, and Dr. Holscher will cover this in a lot more detail today. I believe it's an essential nutrient. Some of the other speakers you'll hear from, we have worked together on making sure people understand all the benefits that are out there. And there's not a perfect fiber out there. It's like, I got to get this one. Blends are probably the best practice of just like a variety in the diet being important. These are my references. And thank you for your attention. I really appreciate it.
Thank you, Joanne. That was wonderful. So we do have a few questions, and some of them we will take to the final panel. So I'll just note there is a question here about how much is too much, and I just want to let you know we're going to defer that one. So if you asked it, know that it has been noted, it's coming. So I first want to start with your chart where you showed the amount of fiber relative to the risk of cardiovascular disease. And I think you kind of came back to it later in your talk, but can you just re-summarize for us? Is it all types of fiber that equally reduce cardiovascular?
Yeah, it's a good question, Barbara. You know, with that study, they just looked at total fiber from food frequencies, right? So, so does that really capture isolated fibers, fiber supplements? It tries to. So I would say, you know, it's soluble versus insoluble is not the ticket there. The ticket is total dietary fiber as measured with a food frequency and getting that from existing data sources. So it's pretty good data. You know, like this is the hard thing when you go back and say, how good was that data? Different people were doing those studies, but in general, most of the fiber sources that we have, there aren't that many that people consume. And when people say to what is the biggest source of fiber in the diet, it's grains. And typically it isn't even whole grains, it's refined grains because they're actually consumed. So I think as a dietitian, remembering that if people never eat your food, it's zero. You don't get any, you know, you get zero. So what was really driving that reaction is what foods that people typically consume. So, and you know, that remember too, that those were quintiles of intake. The highest were 28 grams per day. So you don't, you know, when people say, well, would more fiber be useful? We can't get that from that data. We can only say that we got a huge difference between the lowest quintile of fiber and the highest quintile of fiber. That's a huge dietary signal, and it's on total fiber, the best way we can estimate it in what people are normally eating. So,
okay. And I should just note for people that if you are looking to make a specific cardiovascular risk reduction claim, there are approved claims by FDA, and you should go to the website and look at those very specifically. You recommended eating a variety of fibers, and then you also mentioned that a way to think of variety is probably not so much soluble versus insoluble anymore. Can you give some idea to a food technologist how they would apply the idea of variety when they're formulating a product if they're not going to use soluble and insoluble as the metric to aim for?
see, Barbara, you're just too useful. You ask the important questions. No, a lot of what I've worked in for a really long time is enteral nutrition. So there was a lot of you know, saying which fibers should we use, and in there you're trying to bring in some of these new concepts, so fermentability, viscosity, but still realizing the challenges of the food system. So I think you start with here's the food system I want to work in. Am I going to work in a beverage? Am I going to work a snack food? And then try to figure out more than one fiber that I can add to it. I think it doesn't have to be more complicated than that. And generally, people are like, how much soluble versus insoluble? Obviously, as the fiber methods have varied, there's a different answer for that. But generally, it's like 75% of our fiber is insoluble and 25 soluble anyway. So I don't see any real reason. As you mentioned, there are health claims for the fibers, the viscous fibers that are going to lower my blood lipids. If that's your game, go down that path. But for the average consumer, just getting as much fiber as possible in, not just from one source to say this is a good fiber versus a bad fiber. Anything that is approved by FDA that you can put on your label, to me, figuring out within your product system what you can use and trying to get your numbers. You know, what's a number that's valid? We need about 14 grams. So whatever you can do. And a lot of the, you know, you can see who I've been working with, a lot of the beverage people, the snack food people, it's every system's going to be different because if people don't come back to your product, you know, go back to the low fat and all these things we've tried to do. If they take one taste and it tastes crappy, it's grainy, it's gross, and it causes them GI problems, they're not coming back to it. So I just think that rather than think these are the good fibers versus the bad fibers get soluble at this, I think it's more functional fibers that you can get into your product that don't really decrease the taste and make people turn away from your product, because we really need to get more fiber into the diet.
Very practical advice. So one of the things that drives me crazy about nutrition is something's good for this, but not so much for that. So we have a question about mineral absorption, and that some fibers might be considered enhancers for specific minerals, and yet also maybe they limit others. Can you talk a little bit more about the dynamic between fiber, types of fiber, and mineral absorption, and what a product developer needs to be really aware of when they're making decisions with their product?
Yeah, no, that's a really good question. And I always go back to the dietary guidelines and the nutrients of concern. So less sodium, less added sugar, less solid fat, more fiber, right? And so which of these do we need to worry about? Calcium is always a nutrient of concern, vitamin D too, right? So to me, the calcium data is the most interesting, and the prebiotic fibers that cause fermentation have gotten in because of increasing calcium. So to me, that's a really important signal. That's important because calcium is a nutrient of concern. If you go back to some of the older data on nutrients, and it really is the phytate. Is it the phytate or the fiber long ago that caused the zinc problems in the group of people? And we don't know that, but most of those fibers are really hard to add large amounts of otherwise. I hate to bring this in, but I find a lot of the new plant proteins actually need to be thought about too as decreasing absorption of other nutrients. And a lot of it, I hate to go, why am I saying this? But going beyond fiber, that plants are not all good. There's a lot of anti-nutrients. Dr. Leiner, University of Minnesota, has published some amazing things back in the 70s of, when we take soy, when we take other plant foods, we have to take these anti-nutrients out. So I think a lot of that old problems with mineral absorption probably didn't have to do with the fiber. I think it had to do with other compounds that were in those plants. So I would think if you're eating or you're going to formulate with an isolated fiber, I wouldn't be that worried about mineral absorption. I would be more interested in increasing the calcium and putting some of those fibers in.
And can you, by name, just give us a little more specifics on which fibers would be appropriate for improving?
Yeah, no, I think the ones that have the data are the ones fructooligosaccharides and galactooligosaccharides. So they both, Paula will talk about this more too in her section, but they both use that as their physiological benefit. So they have data, published data. Other fibers, I think that fermentable fibers, you're going to lower your pH in the large intestine. That should increase calcium absorption. So you may not have the data to go down that path, but I think that those types of fibers are likely may have those effects too.
Okay.
But you're right. Like I'm not going to make a claim on it. Like don't go there. That gets the lawyers involved, and that's good. So.
Yeah, bioavailability, more claims, gets complicated. Need food and drug law. So you talked about viscous fiber in particular being a challenge to add to foods. Are there no options for adding an intact and whole food that perhaps doesn't lead to the viscosity in the product and in your mouth, but gets released in the GI system? I mean, I was thinking of something like a chia seed even. Are there not good options for that with viscous fiber? And are we really limited then in the viscous fiber category?
Well, you can look at my past. I've worked a lot with partially hydrolyzed guar gum, right? So that has been around, back since the 80s. We did research on that. And so you take a viscous fiber and then you hydrolyze it to make it possible to go into a solution. And then you do research to see what you give up with that. So it's actually a really hard challenge to say, okay, we know these viscous fibers have this amazing effect of guar gum, but when we hydrolyze it, we're going to have to actually show that we haven't given up some of those benefits. So I think it's a really heavy lift on the science side to say, at what point can I take these viscous fibers and hydrolyze them through some new technology and make them less viscous and still have the physiological benefits I'm looking for? And maybe Paula can get into that as an FDA person too, but like if you are not a hydrolyzed viscous fiber versus a non-hydrolyzed, your clinical studies are going to have to be done with the fiber that you're trying to get in with. So if and that's the hard thing when you hydrolyze fibers, you don't get a clean prep and they're all DP9, right? Or that's the frustrating thing. It's a very chemically difficult work to do.
Okay. So it's interesting. You as a nutrition person, right? Because you see nutrition people and they're always idealistic. We try to be right and, eat the whole foods. And you're saying that that's not really a great option for people who are eating a food that they want to have high in viscous fiber. It's just the reality of it is it's going to be something that's been formulated to work.
And I find that this idea of getting the best nutrition to those that are not the best off. So all of us that have, we have the option to go and get fresh food and do that. But I believe that we're at a point where fiber should be added to foods that people actually consume, rather than make them feel bad. And I'm a dietitian. So people are like, what a fake dietitian. Why have you given up? I never give up. I still want people to eat fiber and I want them to have this wonderful diet. I'll never give up. But I also am a practical person to say, hey, the people that are living on the street and the people that, every food, the most inexpensive food, if we can put some fiber in that food and make it better, we need to do that. I think we have enough data to do that. So to me, this group of people are the people that can make that happen.
Yeah. Okay, good. And then we have a question about cost of functional fibers. And I'm just going to say that we're going to defer to the technology experts. We're the nutrition group here. So sorry about that. We're not going to have an answer for you on that one. All right. So our last question, which is a good question to transition in over to Paula. So Paula, if you want to work on getting your slides up while Joanne handles this question, and she may be punting it to you. So we'll see. So there's a specific question and then a follow-up here. So the first question is xanthan gum considered a dietary fiber? And my second question is that question could be asked of a lot of different fibers. Can people just go to, for example, the USDA's Food Data Central Food Composition Database and look at the fiber value that's listed in that food composition database and make a decision about whether it has fiber for labeling? So if you could start with the xanthan gum first, and then the second is more of the tool for answering that question for other fibers, that'd be great.
Yeah, no, that's great. And Paula can help a lot more than I can. My first thing on the things that are used typically as stabilizers or other food additives, they may have another legal definition within FDA, but still, if they measure as fiber, xanthan gum, to me, that's fiber. So and it's usually used in so small amounts, probably not going to move the needle, but I think of that as a fiber, but Paula can rule on that. Otherwise, if I have to put a nutrition label on my product, I will go to the USDA database and get that information out of there. And that information is the best information that's out there. If I've formulated a lot and added a lot of fibers to my product and my supplier has given me that information, in my final mix, I probably would want to send that out to a recognized lab that has the most up-to-date measures just to make sure that I've got that in, so I would recommend that too. But that's the way you put a nutrition label together. You can use that USDA database, in my opinion.
Okay, so the methods were pretty up to date, in your opinion, for the database.
Yes.
Okay. All right. So with that, thank you very much.
Yes, thanks so much.
We're going to turn this over to Paula, and I believe you have a full hour here, which will include questions. So I'll give you a cue if we look like we're running into the question section, but otherwise, it's over to you.
Okay. Thank you, Barbara. Happy to be here and to be part of the fiber world, I think. I'm Paula Trumbo. I am retired from the FDA. I was there for 15 years, and now I'm a pretty busy consultant. I'm also an adjunct professor at Liberty University in Lynchburg, Virginia. Besides working at the FDA in the nutrition programs group, on the fiber definition, there was a lot of work in amending the regulations on the nutrition facts label. And that was the whole point of coming up with the definition, so that all these changes would occur at the same time. And then Joanne mentioned the daily value, yes. And then also the caloric value for dietary fiber. That was a pretty big deal for a lot of companies, because it did go down in caloric value. I'll talk about that. And my other involvement in fiber has been when I was the senior program officer at the Institute of Medicine, where I was the study director for the DRIs for dietary fiber and macronutrients, as well as the fiber definition. Which overlapped, but the panels overlapped a little bit, but there were some differences in the panel members. This is my disclosures. This is basically them since I retired from the FDA. just a lot of different companies, and then I've just highlighted the ones that were linked to dietary fiber, but I do a lot of everything, including being an expert witness, which is not always fun. Overview of my presentation is talking about the fiber definition a little bit more than what Joanne had talked about, the substantiation of the physiological effects, which is was a really big deal to get that right. And the non-digestible carbohydrates, I'm going to go over those. Joanne already did. I'll talk a little bit about the endpoints that were used to meet that physiological benefit in humans. Then I just have a couple special slides on non-digestible carbohydrates as ingredients, and then also measuring them in food and how that's declared on the food label. And then to get into a little bit this issue of structure function claims and how they work with the fiber definition. And it's still not worked out at the FDA, but there's some key things that I think would be helpful for industry to understand in terms of the similarity and how the science is reviewed. Dietary fiber is a prebiotic. I was just asked to talk about this, if there are any positions by the FDA on this. And then I was also asked to talk a little bit about the definitions in some other jurisdictions, such as in Canada and in Europe, and what's been, how it's been defined by EFSA, and then ultimately Codex and their definition. So Joanne already talked about this, but the FDA definition did come from the IOM definition. And in fact, it was the FDA gave the Institute of Medicine, what they were called at the time, money to come up with a definition, because at the time it was just based on AOAC analytical methods that may capture all the fiber, and it may capture things that don't provide a health benefit. And so it was really not just about analytical methods. Certainly those are still important, but coming up with a physiological effect and a benefit in human health that you would see, for example, in an essential nutrient or an essential vitamin. So these look similar to the IOM definition about being intrinsic and intact, and I'll talk about what that means. That was probably the biggest challenge, is to take those two words and to put them into policy. And then the second, where you actually do need to look at the physiological effect, was the isolated or synthetic non-digestible carbohydrates, both now being 3 or more monomeric units. And so the second bullet, those two, the isolated and synthetic, these are basically ingredients. That's what we're talking about here, is ingredients in foods or dietary supplements. These pertain to dietary supplements as well. And so the intact meant having no relevant component removed or destroyed, and intrinsic meaning or originating and included wholly within a food. So the intrinsic part is more about being part of the matrix, where the intact is the idea that fiber-containing foods contain fiber, but they can contain other nutrients or food components that are involved in the health benefits that you see in these fiber-containing foods. And so it's not just fiber necessarily in like whole grains, fruits, and vegetables, but it could be the combination, or it could be our one or two. We don't necessarily know. And so that's what the intact part meant. So, so once it's removed from the food matrix, and there's no longer these nutrients as part of that food matrix within a food, then it's unclear if it's still going to have those benefits that were observed mainly in observational studies with these foods, but also in some clinical trials. if those benefits would still exist. And so for that reason, the intact and intrinsic, or the isolated, as we call them, the added fibers, which are isolated or synthetic, they have that extra threshold of showing the physiological benefit. So that was the whole point of that. And so it got to be tricky then. Well, how do you determine an intact and intrinsic fiber? Because a lot of times the agency didn't know how these were isolated, what was left over. And so it was really hard to judge whether it was still intact and intrinsic, because a lot of this information is proprietary. And so while it's a great idea, putting it into policy was a real challenge. So when you look at the one guidance that we have out that's specific for, and I'll mention it in a few minutes, for submitting a citizen petition, it's really a fiber that has a specific chemical structure, like cellulose, like pectin, like guar gum. And so it has a specific chemical structure in terms of carbohydrate composition and the non-digestible bond linkages that make it that particular type of non-digestible carbohydrate. So Joanne mentioned some of these endpoints that FDA considered to be beneficial. And I underscore such as, because it's just a running list, but these were the endpoints where there was a lot of evidence at the time for the different fibers. And so they were the priority where there was a lot of evidence. So attenuation of glucose levels, cholesterol, blood pressure, laxation, bowel function, mineral absorption, and energy intake. But certainly since that original list, for example, attenuation of insulin levels has been added to that. So it's ever growing, but as Joanne mentioned, change in the microbiota is more of a mechanism of getting to a physiological benefit. And so it's not a benefit itself. For example, increasing calcium absorption. It's been shown that it's the microbiota and prebiotic fibers that's having that effect. So there's two mechanisms by which someone can get a non-digestible carbohydrate reviewed and determined to have a physiological benefit, and therefore meeting the agency's definition. And that's either through a health claim petition, where there's a strong evidence for that fiber in reduction of chronic disease risk. There's guidance on that. It's not the fastest process in the world, but it's there. And then what is quicker is through submitting a citizen petition to the FDA in this particular regulation 1030. That's where all the requirements are for that need to be in a citizen petition, as well as up above 10114 for a health claim. So this is the link and the title of the guidance that describes what I just said about the chemical structure of the non-digestible carbohydrate and how it makes it unique if it's to be considered isolated and synthetic. And as well as this provides all the information on how FDA reviews the scientific evidence for substantiation of a physiological benefit. So this has been out since 2018. I'm not going to get into all the details of this guidance, but you know, whether it's a health claim, whether it's a structure function claim, or whether it's trying to meet the fiber definition, there are a lot of similarities. And one is that FDA for food labeling requires human studies and primary human studies. So it's not review articles or book chapters. It's basically looking at a published journal article or a manuscript that's been submitted, as long as it's publicly available so it can go into the docket. It's acceptable. It just needs to be in detail so FDA can review the methods, statistical analyses, how the data were analyzed, information about the subjects and the diets. And so that level of detail that you wouldn't see in a review article or an abstract. The food label is for the general healthy population. And so generally when FDA is conducting pre-market type of reviews for anything for the label, it's primarily using healthy subjects and at most high-risk individuals, such as those that have elevated LDL, but do not yet have, in this case, diagnosed coronary heart disease. However, as is the case with health claims, if the mechanism of action is similar in disease subjects for either disease risk reduction or in this case, in providing a physiological benefit, then disease subjects can be considered along with the healthy subject data. It can be exclusively in disease subjects. And, fiber, its action is in the gut. So a lot of these actions, such as attenuating blood glucose levels, such as looking at postprandial levels, the rise and fall of glucose after consumption of a meal, is going to most likely be similar in disease subjects unless there is some sort of GI issue that could affect that. It's important to have an appropriate control so that only the fiber that's being added to the food or provided as a supplement is being evaluated, and there are no other extraneous variables that are being that could affect the results, either in parallel or cross-sectional studies. Appropriate statistical analyses, so that the analysis is being conducted between the control and the treatment or fiber treatment group, and not just looking at change over time. That's not what FDA is interested in. They're interested in seeing the effects, the benefits of the fiber when compared to a control that does not have that fiber in it. And the type of evidence that's relied upon for certain physiological endpoints. So I mentioned laxation is important, but FDA identified certain endpoints for measuring laxation, such as stool bowel frequency per day or over a certain period of time. It's a rate, or transit time. And another issue that was we had run across, and I'm sure they still do, is, for example, postprandial glucose. Usually it's just matching carbohydrate, fat, and protein. So there's isocaloric diets and everything is similar when you're testing the rise and fall of glucose. But in this case, you need to make sure that the digestible carbohydrates are controlled for, because we're looking at the effect of the fiber in attenuating blood glucose from other sources that can contribute to the rise and fall in blood glucose. So that's just a particular specific example when looking at fiber. So when all the studies are determined, which ones are determined to be credible, do not have what we call fatal flaws, and can be used to evaluate the strength of the evidence, just similar to the health claims. In the same way, there's a number of factors that are considered, such as the source of the ingredient. Were all these studies in beverages? Were they in foods? Sometimes they're just added to water, which doesn't really help a lot. So it's looking at fat as well as the number of studies and the findings in terms of, was there a benefit? Was there no effect? Or sometimes there's an adverse effect depending on the endpoint that's being looked at, the size of the studies, and very important, the consistency of the findings. How consistent were these studies in showing a benefit? Was it half did and half didn't? But of course you have to consider all these other variables. There's not a specific algorithm for determining, if it meets the definition or not. And while not required, dose response data is really nice to have. Of course, it's only effective depending on where you are on the dose response curve. But certainly, if there is dose response data, and there was some, for example, with calcium and the stable isotope studies, then that's an added benefit that FDA would consider. So, in addition to the fibers I mentioned before, what this slide is showing you is the endpoints that were used. So the first two were really about coronary heart disease. These are based on health claims, and that's beta glucans. Specifically, it's beta 1 for glucans, because there are other beta glucans that are now getting a lot of attention coming from like mushrooms and other fungal sources, and psyllium husk as a source. And so it was bowel function for cellulose, and the rest of these were for attenuation of blood glucose. And as you see, these are all isolated fibers, except for the last one, number 7, hydroxypropylmethylcellulose, being a synthetic fiber. Oops, did I go too far? There. So since that list, then there's been additional reviews in response to citizen petitions, or at the agency's initiative, like arabinoxylan. That was agency initiated because it is part of the plant cell wall, and I'll explain why that's important. But that and alginate were approved for blood glucose. Inulin and galacto-oligosaccharide were approved for calcium absorption, and high amylose starch, RS2 for insulin, and polydextrose for reduced energy intake following subsequent meals. And in this case, this particular citizen petition requested a specific caloric value of 1 kcal per gram, which is half of what it normally would be. I'll get over that in a few minutes. And then the other one that was based on calcium absorption was resistant maltodextrin, dextrin. Now, one of the biggest difficulties we had when I was there was this intact and intrinsic, as I mentioned. And when you start playing around with tomatoes or soybeans or corn, cornhull, oats, whatever the source is, how much do you play around with it so it's no longer intact and intrinsic? And that was a real challenge for FDA. So what we came up with was, well, what do all these plants fibers like tomato fiber, citrus fiber, soybean fiber, cornhull fiber, what they all have in common was they have a plant cell wall, and the cell walls are very similar across these plant sources. They have cellulose, pectin, lignin, which is a given, even though it's not a carbohydrate. The beta glucans, the 1,4-glucans, and arabinoxylan as a hemicellulose. That's why arabinoxylan was looked at, to add an additional plant cell fiber. And so the agency decided, well, if this fiber source contains 2 or more of these plant cell wall fibers, that it can be in varying proportions and levels, then it would meet the dietary fiber definition. So what it basically did is it pulled in all of these mixed fibers, like citrus fiber or cornhull fiber, to meet the fiber definition, because those individual fibers had been reviewed and determined to have a physiological benefit. Now, also, let me say real quick, because I'm thinking about this, is only one physiological benefit is necessary to meet the fiber definition. Okay, next. And so the additional ones, these are the more recent ones, would be the modified wheat starch RS4 that had a couple go arounds, and then was approved based on attenuation of postprandial insulin. Most recently, glucomanins for cholesterol and gamma casein for postprandial glucose and insulin. Now, to talk about ingredients, just a couple of things I wanted to mention, just to make it clear about what companies can and can't do. Even though it's a non-digestible carbohydrate, but it doesn't meet the dietary fiber definition, it still can be added as an ingredient. It just can't be declared as a dietary fiber unless it has been determined to have a physiological benefit based on FDA's review. The food can include ingredients that do and do not meet the dietary fiber definition. That would require, and I talk about this further, but I'll just go ahead and mention now, it would just be understanding, how much total fibers or total non-digestible carbohydrate is there, and looking at formulation sheets to determine how much of the NDCs that meet the definition were added and how many did not, and working backwards per serving, for example, to determine what can be declared on the diet on the nutrition facts label. And so mixtures can be reviewed. I don't know of mixtures that FDA have been asked to review. I know in Canada they have, but if they were, each individual fiber within that mixture has already been reviewed and determined to have a benefit, then it doesn't need to be submitted to FDA. That's a question we got a lot on. So it's kind of like the plants. So now I'm moving on from ingredients to measuring dietary fiber for declaring them out on the food label. And Joanne talked about this. There's these newer methods. Some call them the Codex method or the McCleary method, but they're able to capture and measure these lower molecular weight non-digestible oligosaccharides, which is great because when FDA was relying upon chemical structure or analytical methods only, that was not available at the time. And besides measuring total, there is the method also for soluble and insoluble fiber, which I'm going to talk about at the bottom here. So I already mentioned that, if you have a mixture of non-digestible carbohydrates that do and do not meet the definition, formulation sheets work, or if you have an analytical method that measures the specific fiber that does meet the definitions, you can certainly do it that way. So the caloric value is oh, I'm sorry, that's a typo. For soluble is 2 kcals per gram, so that went down. And what did not change was for the insoluble, it was 0 kcals per gram. But the point I want to make here is that that whether it meets the dietary fiber definition or not, all non-digestible carbohydrates are declared as part of the total carbohydrate declaration. So I think there's been some confusion there as well, but yes, and that's measured by difference. And so it would be the by difference method. So that's how that would be done. But soluble used to be 4 kcals and now it is 2 kcals per gram. And that came out of the dietary fiber definition report also, and the rationale out of the Institute of Medicine. So Joanne mentioned that soluble and insoluble are voluntary and are listed as soluble and insoluble fiber. And I know that it was recommended by the panel that came up with the definition that a better way of sorting out the fibers rather than by soluble and insoluble fiber is preferred. and such as viscous and non-viscous, where the viscous would have more of the physiological benefit as opposed to the non-viscous. The issue is that FDA must be able to enforce what it regulates. So, and we submitted, it's called an advance notice of proposed rulemaking, AMPRM, and this is probably where we got the most comments, is that there was not at the time a method to sort out viscous and non-viscous and link it to physiological benefits, and to have dose response data, thresholds, or whatever to determine whether it's viscous or non-viscous. So the agency was just not able to go that route, where there are methods for soluble and insoluble fibers. So that's the reason why it's still that way. Okay, next. I was trying to move this myself, Cindy. Next slide. Now, this is just a link. If you go to the FDA food labeling website, there's now a whole section on fiber, which I'm glad to see, because there's a lot of different pieces and parts, and the different citizen petitions are now posted there, which is very nice. And so as part of that, there are some nice Q&As about dietary fiber labeling, where anyone can go to. Next slide. So I want to mention about structure function claim substantiation, where now we're talking about a claim that's the role of a nutrient or a dietary ingredient in the body and its effect on the normal structure or function. And these do not require pre-market approval or review like dietary fiber. But the substantiation is very similar, because for most of these, we're looking at mostly physiological effects. For some of the calcium reviews, we also looked at bone mineral density, which would be structure rather than function. And so my take and my view is that if FDA has reviewed a particular fiber and determined it meets the dietary fiber definition, then it basically has conducted a structure function claim review. They're very similar in terms of the type of information that's needed, study design, and so forth. And so certainly those can be used for that purpose. Next slide, Cindy. So this is the guidance. It's been out for a while. It says substantiation for dietary supplement, but it's also the agency considers this guidance to be for conventional foods as well. It's just at the time when structure function claims came about, they were specific for dietary supplements under DSHEA. Next slide. And then I was asked to talk about prebiotics. Does the FDA have a definition for prebiotics like functional foods? No, there's not one for functional foods. And CFSAN really doesn't have one, but I did find one for anyone who's interested in the drug center, CEDAR, in their division of complementary and alternative medicine products. So it's not surprising, but here's the definition. Non-digestible food ingredients that beneficially affect the host by selectively stimulating the growth and or activity of one or more limited number of bacteria in the colon. They mention oligosaccharides are commonly prebiotics, so they acknowledge that in this document, which is a guidance for industry. So this is the link where you can go if you want to read more about that. Next slide. And so prebiotics, you will see them on foods and dietary supplements. These are some of the structure function type claims. You will see prebiotic fibers promote digestive health, nourishes and replenishes gut flora, promotes the maintenance of good bacteria. So these are not adverse to FDA's thinking as long as the evidence is substantiated. then certainly these can be used on food labels. And so I just wanted to mention that. Next slide, since I was asked to just briefly talk about that. Now we'll go to other jurisdictions. Health Canada's definition is very similar to IOM, FDA. They're just called a little different, and there are some nuances. Instead of being intact and intrinsic or being natural fibers, they're called traditional fibers. The added, isolated, and synthetic are novel fibers. And again, a degree of polymerization of 3 or more. And so it has extended the size of the fibers that can be considered. Next slide. Now, here's where there is a difference between the United States and Canada. So first of all, they have recognized physiological effects. So they have a list. FDA does not have a list. They have a list of what they've used in the past, but not a list of what they will use only in the future. But what you see missing in this is the word beneficial. So it's just physiological effect. So the first 3 clearly are beneficial: improving laxation, reducing cholesterol levels, attenuating or reducing blood glucose or insulin levels. The 4th one, though, is where the 2 diverge, and that's providing energy yielding metabolites through colonic fermentation. And so here we're getting into the microbiota and as a prebiotic. And again, FDA sees this more as a mechanistic effect rather than a effect that is beneficial itself. It can lead to a benefit. So that's where there is some differences. And here's the website for that. Next slide. Okay. So while we call them, these are, we would call these function claims. They call them health claims in Canada. Here are some that have been reviewed and approved. And here's where I had mentioned their mixes have been reviewed for glucose and cholesterol on this polysaccharide mix. And then psyllium fiber and reduction of blood cholesterol that is similar to the United States FDA. And we have that as a health claim. Next. And then these are 2 more that Canada considered to be beneficial in terms of laxation, giving a particular amount of fiber that needs to be present. Next slide. The European Union, again, is very similar to the FDA and to Canada. My last slide, I guess it could have come before this, because they are pretty tied to what Codex is going to come up with. And so they try to be consistent, very consistent with the whatever Codex comes up with. So it does look very similar to that. Again, it's 3 or more monomeric units. 1 prong is the naturally occurring. The 2nd prong is obtained or isolated from food raw material by these methods. And then finally is the synthetic. So it's all very similar, being 3 or more monomeric units. So these are examples of and in this case, this represents a lot of countries where the degree of polymerization is now down to 3. And it's nice because we do have the methods to measure these now all at one time. Next slide. So these are function claims that EFSA committees reviewed and gave a thumbs up on. And what I'm showing you, they have an inventory list. It's really nice, where they have all their approved they call them health claims. Here it would be a function claim. And so these are the ones that I could find that are on the inventory list. And as you see, there's the similar endpoints to how FDA reviews these different fibers. The only one that would be different would be fecal bulk. FDA does not consider fecal bulk. It's rate, laxation rate, and transit time. Okay, next, or stool frequency, that's right. So the one disease claim they do have is on the barley beta-glucans. Again, this is 1,4-beta-glucan, and cholesterol lowering, reducing the risk of heart disease. So that's, EFSA reviewed that. Okay, and then this is the Codex definition that took quite a while to get agreement upon, but that's not unusual at Codex. So it's very similar to what you've seen all along. And I can say that while these discussions were going on about coming up with the Codex definition, the IOM definition was around and was really serving as a blueprint or template for a discussion on developing the Codex definition. And so that's why there are these similarities. So very similar, but as Codex is very famous for doing, sometimes you'll see a little asterisk and go down the bottom and see, for example, the double asterisk with 10 or more monomeric units. It will say it's up to the national authorities to decide if it should also include the 3 to 9 monomeric units. And so that's what's being done here. Of course, anything coming out of Codex is voluntary. So this was left up, this particular part of the definition was left up to the discretion of whatever country was voluntarily using these to make policy decisions. I think, next slide, Cindy, I think that's it. So thank you very much for your attention. This is my email address, paulatrumbo@yahoo.com. If you wish to ask me any questions that I can't answer today.
Well, Paula, that is very generous to offer that. And I'm going to tell you that we have a very rich list of questions here. So feel free to be quite brief and concise with them.
Okay.
And we may end up having you go onto the Q&A board and answer a few if I don't get through them, but I'll let you know that at the end. Okay, so I've ordered these to kind of make sense with flow. Let's start at the top. We have a couple questions about categorizing fiber. Can you just remind everyone and give an example or two of an isolated fiber and how that differs from a synthetic fiber?
So the isolated is going to come from a food product, and then it's going to undergo whatever processing methods are required to get it to its final stage, such as milling and using chemical aqueous extractions. Sometimes it's a combination. And so that's really what isolated means here. So it's just come from a food source where the synthetic is synthetic. It's starting with a particular chemical structure and making the fiber. And I would say the one example where there is an overlap would be, say, the shorter chain fructooligosaccharides. They can be made either through isolation or through chemical synthesis. Okay. So that's the one difference.
Okay, so this one might be a really quick one. Okay. I'm gonna read to you a few specific fibers, and I'd just like you to react to whether they would be intact or intrinsic. And then at the end, you could probably give a brief, how did you make that determination? Like, what was the rationale for? Okay, so is oat fiber intact, intrinsic or not?
Well, the agency kind of got away from that, and that's why the guidance that came after the definitions provided more explanation. So it's a mixed plant cell wall fiber. So it's I wouldn't say it meets the dietary fiber definition because it's a mixed plant cell wall fiber, an oat fiber.
And wheat fiber?
Same.
Okay, rice fiber?
You got to be, you got to be careful. You know, some of these, and let me talk about that real quick. Some of these common use names for fibers in the ingredient list can be really confusing. And so it's sometimes hard to know what that fiber is. But if you're just talking about, in this case, wheat fiber, that's fiber that's been isolated from wheat, then that's considered to meet the fiber definition.
Okay. And the last one was sugarcane fiber. Same thing?
Yes.
Okay. All right. So this is a very specific question. And if it's going to be too much to answer, I want you to just say we will post it instead in the chat. So the question is specifically how FDA deals with non-digestible oligosaccharides of DP3 to 10 that are captured by the AOAC methods, but not considered dietary fiber by the FDA. And the example is xylo-oligosaccharides and salo-oligosaccharides. How should they be labeled on the nutrition facts panel?
Okay, yeah, I had a slide about this. So they're labeled, they're all declared, whether they meet the definition or not, they're all declared as total carbohydrate, okay? But if you have a mix of non-digestible carbohydrates that do and do not meet the definition, whether they're an oligosaccharide or not, then it needs to be determined what portion of that non-digestible carbohydrate meets the definition for that particular one or two fibers, depending on how many are in there. And that's where I was saying formulation sheets are very helpful because you know how much you're adding of each ingredient. And so you can back calculate to know what percent or what portion meets the fiber definition and what does not per serving.
Okay, perfect. Now we're going to ask a series of hopefully short answers to questions that covered the demonstrated human health benefit areas, so the efficacy. Okay. Quickly, number of randomized trials that FDA is looking for to prove a physiologic benefit.
So they never say how many. And that's because there's other factors that need to be taken into concern when thinking about the strength of the evidence, okay? So as I had in that one slide, it's the sample size, it's the consistency of the findings. So you could have 20 studies, well designed, but 10 of them showed no benefit and 10 did. Well, that's not very consistent. And so I think, you know, FDA would have to really then dig deeper to see, well, why is that? Is it the subjects? Is it the duration? Is it the way that the diets were designed? Is it a big one is baseline levels. Are these normocholesterolemic subjects? Are they hypercholesterolemic subjects? Because if they're hypercholesterolemic subjects, there's more room for improvement. So there's a lot of factors that have to go into considering the strength of the evidence and if it meets the dietary fiber definition. Now, I can say that the agency likes to have what are called comparables, at least 3 comparables. They would all have to show a benefit. So that doesn't necessarily mean studies. It could be one study had it's more than one dose. That happened in the case of one of the calcium stable isotope studies. So there were 2 levels and 2 results. And then there was another study, I believe, a second study. And so there were 3 results from 2 studies that showed a benefit. And it was a stable isotope study. It was very well designed, coming out of Purdue University. And it was consistency. It was the design of the study, and the dosage of the non-stable isotope was within a decent range. And there was dose response data. So it just depends.
All right. Quality and consistency seem to be big factors that influence this answer. Can you clarify, you had a slide where you talked about whether you can include studies with people who have medical conditions, and you went very quickly. I just want you to clarify for everyone. Can you include and use as primary evidence a study that excluded anyone who did not have a medical condition? So it's a study that is on people with a specific medical condition only. Is that evidence to be used?
Well, it depends on the medical condition, and it depends on the endpoint that's being measured. Okay, so the example, the activity, I mean, fiber does a lot of stuff because it doesn't do anything, because it's just going in through the gut, and then when it gets down, it's getting digested. It's not like itself is being absorbed to have all these systemic effects. It's something else, maybe. And so obviously the one area that FDA would take a great pause, and this is talked about in that 1030 citizen petition guidance, is if they have some sort of bowel issue. So IBS, or have one of those tubes, or there's just something not right about their GI system, then that's where those type of studies would be difficult to use, because that's where things work. If it's inhibiting glucose absorption or whatever, or calcium absorption through the prebiotic effects. Okay.
Yep. Okay, you mentioned that just adding fiber to water for testing of efficacy is not very helpful. Can you just elaborate on that?
Well, okay. So let me give you an example of where that has happened. And so there have been some studies where fiber was added to water versus something else, and the rise and fall there was no rise and fall for fiber, but the other, which was some sort of carbohydrate, did. Well, that's not looking at the effect of a fiber on postprandial glucose of a food, and looking at how fiber is affecting the absorption of the carbohydrates or monomeric units coming from other carbohydrate sources in that food. That's why I said it's important to match. That's really like a glycemic index study. Well, we know fiber doesn't have much of a glycemic index compared to other carbohydrate sources. So that was an example of where it just wouldn't work very well. So, and that's talked about quite a bit in the guidance, just because there's a lot of studies that we would receive in a citizen petition to substantiate attenuation of blood glucose.
Okay. All right, here's one. You have a mixture of a fructooligosaccharide that would support mineral absorption in the same food with a resistant starch for glycemic
RS2.
Is it okay using a mixture like that to make the claim for both the mineral absorption and the glycemic index without doing a clinical trial on that specific mix?
It's okay.
Okay, good. Yeah. I like these clear answers.
Yeah, because they were reviewed individually. They were reviewed individually. And there's always going to be other things in there. These synthetic and isolated fibers that are being approved are going to be added to all kinds of foods and infant formulas even, and beverages. And so there's always going to be other things in there that could affect it. So that's why the studies really need to look at the independent effect. We can't control what other nutrients are doing. That's too complicated. That's like dietary patterns, which I don't want to talk about.
Okay. All right. So here's a really good philosophical question. So if small amounts like 1 to 2 grams of fiber are considered healthful, and yet the standard for making a good source claim is 10% of the DV or higher, how could a food that has a lower amount still message around it? So maybe, statements of facts or other options that are below the 10% DV and communicate to consumers that there's fiber present, maybe even beyond just saying it's there.
Yeah, so now we're getting into nutrient content claims. So there's certain words you can and can't use. And so the safest way of doing it is, I always say, is to do it for a nutrient that doesn't have a daily value, like EPA, DHA, and trans fat, and where you make a material or factual statement, I should say, a factual statement which contains X grams of fiber or the specific fiber. That's a factual statement. So that's not considered a nutrient content claim. And so that's what, they did, or I guess still do, probably don't, well, they don't do it anymore, but they used to with trans fat. So if you make a factual statement about it and how much it contains, then that's fine.
Okay, so a statement of fact would be a way to do it for these lower levels that don't meet the good source.
Yeah, you can say how much is there.
Made with psyllium seed, made with...
Yeah, made with, and yeah. So if you want to do it that way too, of course, and some use, in the if you don't have a facts up front type of information there, then certainly it would be fine to do that. Sure. Okay. There's ways to get around that.
All right, so we have another relatively general but more specific question, and then we're going to end with a nice philosophical question that has a lot of meat to it. So thinking about psyllium husks, seeds like chia and some other seeds and products that are shown to help people feel full or to be satiated when they're restricting calories, right? So they're trying to do weight management, they're restricting calories, and they just want to feel better as they're doing it. It's a subjective measure. So you didn't list that as one of the areas that has been used to make substantiate a fiber, and yet it would be a very relevant use for many of these fibers and benefits that I think Joanne talked about even. Can you comment on how how feeling full can be used in either substantiating or in messaging if it hasn't been proven to reduce total calorie intake per day?
Well, satiety, hunger, all of those endpoints that are measured when testing this is not sufficient for meeting the dietary fiber definition. Again, it's more considered a mechanism because you can feel full and still eat a lot, like me.
So you're saying the outcome that has to be measured.
It's the outcome is energy intake. So that's what is on the list.
Okay.
So when polydextrose was reviewed, the reviewer, she collected all that information on hunger, satiety, fullness, whatever. And it was kind of supportive information to understand why there would be a reduced energy intake. But energy intake is the true endpoint. That's the benefit.
Okay. So if you fail at the energy intake, you're out of luck, even if you felt great. All right.
And there's good discussion about this in that 1030 guidance.
Okay. All right. So here's some more philosophical question that'll take us through the last 2 minutes here. I'm going to read it so we get it right. Some product manufacturers appear to believe that an isolated or synthetic non-digestible carbohydrate that FDA is approved as a dietary fiber is suitable for use to make health claims involving fiber. Can you elaborate on your understanding of how people have blurred that and said if it's been approved to as a fiber for a certain health benefit, how that has blurred over into making claims about that fiber and health benefit in more of a health claim manner?
Chronic disease and diseases. Health claims are pre-market review. And if you notice, it said on the list, there's two ways to get a fiber, through a health claim or through the citizen petition route. It doesn't include qualified health claims. Okay, I know that sounds complicated, but I just want to mention that. So it's got to be an authorized health claim that meets the significant scientific agreement standard, that require FDA approval. So if a company is saying, let's see, GOS reduces the risk of osteoporosis, that's an unapproved health claim and is a disease claim. And those are the kind of claims that FDA has no problem going after, because that's really a low bar and easy to write a warning letter on. So that's a big no-no.
Okay, so I'm going to just ask you, Paula, to go into the Q&A section. I will have sent you a chat that tells you one other very specific question that we'd like you to answer, and that will go to the individual directly in the Q&A. So if you had something there as a follow-up to the question we just asked, please go there to find the answer from Paula. With that, we're going to turn over the webinar now to Bruce Hamaker, who will be talking about more of the emerging areas of research and get into a little more on these mixed fibers too that seem of interest. So with that, I'm going to be quiet and we'll hear from Bruce.
Okay, thank you, Barbara, and hello, everybody. Can you see that? Barbara, is that?
We can see your slides, thank you.
But is that thing on the top too big? Let me see. Hide floating.
I think it's fine. You don't need to fiddle with it unless it bothers you.
Okay, there we go. All right, so as Barbara said, I'm going to talk about sort of what's on the horizon and in the way of fibers and their function in the gut and even somewhat related outside to whole body health. These are, these are research areas, but I hope that also this will give some practical kind of thinking to you about how fibers function in the body and in the gut particularly, but also in ultimately, perhaps down the road a bit, but in your selection of fibers. So I'm in food science at Purdue University. I'm also director of the Whistler Center for Carbohydrate Research. Some of you may have heard, some of you may be in companies who are member companies of the center. We do sort of a broad range of research in the carbohydrate area, but it also hits this area in my group and another laboratory, Steve Lindemann's lab. My background also includes nutrition. I have a master's degree in nutrition, kind of the nutritional biochemistry area. I started out as actually a PhD student in nutrition and still love nutrition, but I went over and got a PhD in food chemistry. I have a postdoc also I did in a human metabolic facility in Lima, Peru for a couple years. And that, I think, kind of got me off in this area of the intersection of food structures and carbohydrates specifically for what we're talking about today, and dietary fiber and the gut, whether it be upper GI tract and epithelial cells or the gut microbiome, which which I'm going to talk about. I have just one, I think, disclosure that really counts for this talk, and we have a small startup called Right Carbs that I should mention. And let me get going. So I have 30 minutes or maybe less than that now, isn't it? Like 25 minutes. What I would like to start my talk on is that the whole concept of kind of the next step into targeted function of dietary fibers, or fibers as Joanne defined them, which is correct. So really, I'm thinking of added fibers, but also sometimes intact intrinsic fibers. And that area is really how one can go about understanding this system and this intersection of fibers with gut bacteria, the gut microbiota, in terms of how one can align fibers to get certain kind of responses, and particularly to support certain groups of bacteria or even specific bacteria in the gut. So to start that out, I'm going to give a very quick kind of primer on how we think about this, and I think how you should think about it too, because when we first got into this kind of work, really you have to first think about fibers from the perspective of the gut bacteria. So you know that there's a lot of bacteria in the gut. There's over 1 trillion bacteria. And you know, at the taxonomic level, if we go to species, there's something, who knows, but let's say there's around 500 species of bacteria in the gut. But at the strain level, and that's where very specific, the specificity of interaction of the bacteria and the carbohydrate structure really exists. Maybe there's around 10,000 strains of bacteria. And they exist in an ecosystem, of course. And there's a number of people who study that and really put out the argument that that there needs to be a stable ecosystem that creates a low inflammatory gut with good barrier function, you know, keeping a good barrier between the gut and the body, the systemic part of the body. So just a few more words about that at the bacterial level. If you look at one bacteria, any bacteria that cannot digest and utilize all kinds of fibers, right? It could be relatively few, maybe even less than 10, or it could be like up around 30, maybe even somewhat more than that. But maybe an average amount might be about 15 to 20. In that bacteria's genome, there are parts of that, that genome that encode, you know, proteins that relate to certain kinds of carbohydrates. And those proteins are binding proteins to that carbohydrate and, of course, enzymes to break them down. To get sugars or oligosaccharides, some bacteria can import those. Like Joanne mentioned, for bifidobacterium lactobacillus, they're really good at importing oligosaccharides. But they all break them down, or they import them as simple sugars that break them down into monosaccharides or simple sugars for energy. So the other thing to say is that bacteria have evolved over a long time, right? In this highly competitive environment for food, evolved strategies and mechanisms to get at not bacteria, but certain kinds of carbohydrate structures. And each bacteria will have different strategies. You know, maybe they're feeding, you know, inulin comes along and lots of bacteria can utilize it. Lots have that ability, and they just try to get some of it. And another strategy would be a very particular complicated structure comes along. Very few bacteria can use it. And one bacteria can, say, outcompete other bacteria on that. So it's a really highly competitive environment. Enough on that. Okay, so a little bit more about structures. So there's chemical structures that involve different monosaccharide or sugar, simple sugar, 1-unit sugar combinations. An example of that, a simple one, is that fructan phos or inulin, because it just has fructose. Often it has a glucose head on it, but other than that, it's just fructose. And then it's one linkage, beta-2-1 linkage. So bacteria basically need one enzyme. They don't have to worry about trying to synthesize all these different, kinds of enzymes and binding proteins, so forth, to break these structures down. Another one's polymer size. Another one's into polymers or even some oligomers, branching distribution, and then linkage types is really where it's at, both sugar composition and linkages. That's where enzymes go in. That's where it happens, right? They're able to bind into certain regions of the carbohydrate and cleave, hydrolyze that bond, release it. Okay, the other thing is that there are different physical structures into the insoluble fiber area. So it's been covered by Joanne and Paula both, but insoluble does not mean non-fermentable. And bacteria know that best, because they have developed a number of different strategies to get into like cell wall matrices that Paula mentioned, and to get at those sugars, to get enzymes in there. Here's a way that some bacteria in the Firmicutes phylum they have these appendages out from the cell wall surface here where my pointer is, and they can switch out this kind of scaffold with different enzymes, binding proteins, and then eject that into a matrix. So they're all after those kind of carbohydrates also, but they have restrictions. Some of them are so densely packed, the cell walls, they can't get at all those, and it's all based on time, right? If they can't get it before that goes out into poop, then they lost it, right? So like Joanne said, like cellulose might only be 10%. That's particularly hard for bacteria to get to because it has a semi-crystalline structure. So there's those things. There's even viscosity related to access of bacteria, how they can access fibers. But viscosity, if it's a fiber in the gut that can be broken down quickly, viscosity decreases quickly. But something like psyllium that's not well fermented at all can maintain that viscous environment in the gut, and that changes how bacteria can even get to other fibers. Okay. So this looks complicated, but I'm just going to make a point here that some bacteria have this high specificity for, I'm sorry, starting the wrong place. Some fiber structures, or let's say bacteria, some bacteria have a high specificity towards certain fiber structures. So here's a bacteria, a genus you may not have heard of or may have, Anaerostipes. It's a butyrate producer, so there's interest in a lot of these butyrate producers because they have a tendency to lower gut inflammation. They have some other good things. It's not the only thing going, but that's one target of research. And so this Anaerostipes, if you look over at this, what's called a genus abundance plot, but go over to where these arrows are, and you see this is a time course in vitro assay. It's from 0 time to 24 hours. All I want you to do is look at the gray part. That's Anaerostipes. It went at 0 time from less than 0.5% relative abundance in 24 hours to around 22 to 27% for these two unique kind of beta glucans that, to give it some pizzazz, they happen to be in a mushroom from the Amazon, but that's just the way. I won't go into that story. This is a paper out of my group, and it also increased butyrate production quite significantly, and that's then a fiber structure that has a very specific kind of relationship with the bacteria. that same fiber structure, if you change the branching structure of that just a little bit, take off some branches, you lose that ability to match with anaerose stipi. So just to say, it's very specific structurally speaking. So I sort of brought up this idea of simple structures versus complex structures. And just to say that if we look at oligosaccharides in the diet, whether they're natural or whether they're added, I think most probably are added, but not all. You know, inulin I've included in here because it's kind of a big oligosaccharide or mid-sized saccharide. You can sort of rank those by whether they're structurally simple or structurally complex. Here we have, as I mentioned, fructooligosaccharides, that beta-2,1 linked fructan or inulin is structurally simple. Lots of bacteria can use it and benefit from it, but still probably some bacteria are going to outcompete other bacteria based on like what size that is or some other perhaps aspect, probably mainly size. But then we get to galacto-oligosaccharides, a little bit more complicated in structure, resistant maltodextrins, rather complicated in structure, and here are rabino-oligosaccharides, which are quite complicated in structure. We have resistant starch. It's insoluble, right? But it's highly fermentable. Most resistant starches are quite fermentable, at least in the transit time that they're there, that they are present in the gut. But they're slowly fermented. Not to get into the reasons for that, but it has to do with the fact that they're insoluble and a little harder for bacteria and enzymes to get to. We look at polysaccharides. You know, structurally simple cellulose is structurally simple. It's, you know, it's just a glucan, right? But it's hard to, well, it's indigestible by our own enzymes. The beta-linked, beta-1,4 linked glucan, just one, again, it just has one kind of linkage, but it's hard to get to. I mentioned earlier because it's in a partially crystalline structure. It's hard for those enzymes to get in there, but they can. Just takes a long time, and it's only partially fermented then. But then, like beta-glucan, a typical beta-glucan I'm mentioning here is like an oat beta-glucan, which is highly fermentable, opposed to what I was talking about from that mushroom earlier, which is a branch beta-glucan, and that one was insoluble, I didn't mention. This is soluble. Pectin is structurally more complex. Arabinoxylanes are quite complex structurally. There are other ones too. These are just examples. So here's a study we did a while back on how structures, this is arabinoxylans, relate to fermentation rate. And I'm not going to make any statement on tolerability, and Heather's going to talk about that tolerability. That's her talk. But structures, but fast fermenting fibers, whether they're intrinsic or functional, if they ferment very fast and produce a lot of gas, for people who are susceptible to that, it may not be tolerant. Here, we have an in vitro fermentation profile here, and FOS is, you cannot see it very well, but it's the purple one where I have the pointer. So it was very fast fermenting right out of the gate, right? And here we have a rabinoxylan. This one is from sorghum bran. It looks complicated, but it's not really complicated. These are arabinose branches. This xylan backbone just has one linkage type. There's just two linkage types on the branches. So bacteria can digest that pretty quickly and utilize it, and that's what happened. It was fermented just as fast as FOS, actually. But here we have a very complicated structure, both sugar combinations and linkage combinations that was extracted from wheat bran. It doesn't represent all of wheat bran, you know, make that condition, but it's there, and it's fermented very slowly. But in the end, it's totally fermented in this study, in vitro study. So, it brings up a really quick point I want to make about classifying fibers for gut health. You've heard, and that in the regulatory world in the US that it's voluntary to put soluble and insoluble. Doesn't mean that much to us as scientists anyway, and we tend to think of fibers as fermentable versus non-fermentable. Because we're interested in their effect in the gut microbiome being fermentable. Non-fermentable, we've heard from Joanne and Paula, those have good, laxation properties too. Not to say that one is good, the other's not. And then prebiotic versus non-prebiotic, which is, I've been on some papers, a paper on the definition and other papers on, even we produced some on prebiotic effect. It's still a little bit vague, but there's pretty good definitions out there now. So anyway, we think of fiber fermentability on a spectrum kind of basis, from non-fermentable all the way to high rate of fermentation. Those oligosaccharides like FOS, inulin would be some other ones too, that sorghum, arabinoxylan would be up here. And then getting into chemically more complex fibers, still soluble, but rate of fermentation is decreasing. Psyllium would be here. A lot of it's not even fermentable. But then getting into the insoluble fibers, if you have accessible matrices, and just include resistant starch there too, those are highly fermentable or can be highly fermentable fibers. And then into less accessible matrices or not accessible or very uncommon kind of fibers that there might not just be one bacteria that are one kind of bacteria that could even utilize that, even maybe say at the strain level. Okay, we got into another, I'm going to move kind of quickly. I know, Barbara, I have like 10 minutes according to what I'm thinking from my watch. So we got into also, along with this, the idea of fiber responses in individuals. So, and you may be thinking that as you're watching this, well, we all have different microbiota communities, what's the, is there a point, and these fibers act in similar ways across a population. And, a lot of times, maybe not, and I'm not, it seems like I'm picking on FOS, really not. And there's some beneficial aspects of FOS for sure, but this is a study we did in 10 individuals. This is in vitro. It's published in this journal MBio in 2021, not that long ago. But here's what's called a beta diversity plot, not get into that reason. But if they're all going in the same direction, the arrows, then the response is the same. And if the arrow's longer, it's a larger response. But here we saw lots of different responses. It fit into, this fits into an idea that we presented in that journal and the year before that in a perspective paper, New View on Dietary Fiber Selection for Predictable Shifts in Gut Microbiota. And it relates to what we call low specificity versus high specificity fibers that relate to structural complexity, chemical and physical, that I've talked about, and also bacterial competition for that. Some that are not that common might fit down into this high specificity. But the idea is that low specificity fibers, you're more likely to get different responses among individuals, but high specificity fibers like that beta-glucan and anaerostipes I showed at the beginning, you would get more similar responses. And here is that fiber, that same beta-glucan I mentioned before. In this study, we see that almost all the arrows are going in the same direction, right? And they're longer arrows too, meaning the response is greater because they're very specific towards feeding in this case, that Anaerobic stipes bacteria. So this is just another way of showing it, and I'm not going to, but then go into really much more discussion on it, other than this is relative abundance on the y-axis of that bacteria. Here's Anaerobic stipes. Here's bifidobacteria that, would benefit from FOS. And in the 10 individuals, you see the response here. With the beta-glucan, that mushroom beta-glucan from the Amazon. And here's 2 that didn't respond, but they didn't have Anaerobic stipes. So only 8 of the 10 had that bacteria. And then if we put those on the same y-axis scale, you see that the response was greater. So another question, or perhaps a bigger question, because we were just lucky at that point to find that, is if you give us a fiber, could we find if you give us a bacteria that you wanted to promote, or even a group of bacteria, could we find the fiber to match it? Only to say that we have, with Faecalibacterium prausnitzii, which is almost in everybody, that we developed a protocol, and we did identify then a matched prebiotic that in all cases but 1 of the 10 donors increased that bacteria, promoted that particular bacteria. This is the idea, isn't it? That you have a matching kind of fiber technology where you can specifically address and support a particular bacteria, but it also, we've used that in groups of bacteria and mixtures. And so for 5 minutes, I'll just give you a quick snapshot of something we've done. We've worked on mixtures actually quite a bit in the last few years, but this is a fiber mixture that we did with our partners at Rush Medical School in Chicago. Did a clinical study on Parkinson's disease patients. And I'll say right now, from the regulatory side, Paula, it's not very clear, isn't it? This is not what we're talking about when we're talking about fiber claims. But anyway, this is like kind of what's, I think, on the horizon that's going to be coming up more and more. So anyway, the idea here is that instead of trying to get that exact, that match for a particular bacteria, it's into groups. And here we made these should represent groups. They don't look like it, but it should. And here we took 4 different fibers that when put together supported, this is called a heat map, but all you got to look at are these red. This is promotion, means red of that bacteria, support and promotion in an in vitro fecal fermentation. And you can see that those 4 fibers complement each other. And each one of these groups have known beneficial bacteria in them. Okay, so then we took that fiber, and up at Rush, they did a clinical study, short-term, open-label study. It was not an RCT study, which we hope we're going to get here at the end of the month if we got money to do a randomized controlled trial. But it was interesting enough that we got it published earlier last year in Nature Communications. It's a highly tolerable fiber mixture. I mean, we made it for that. We selected the fibers so that it would be so. And here's some just quick snapshots of, in 10 days, consuming 20 grams a day, 10 in the morning, 10 in the afternoon or evening, that proteobacteria, which is a phylum that has a number of pro-inflammatory bacteria, decreased markedly. Barrier function, not get into the details, improved. And localized inflammation, a biomarker called calprotectin, decreased significantly. And here's a brain inflammatory marker that was significant in decrease in 10 days, which is called neurofilament light chain, which of course I knew nothing about, but now know enough to be dangerous about on that. We also worked, our colleagues at Rush and ourselves, making the prebiotic fiber mixtures. worked with a group at Caltech, and this is a paper they published in 2022, showing, I'm just going to show, these are called microglia. And in the wild type, this is a mouse study. Don't want to get into the nitty gritty here, but you can see these microglia, healthy microglia. This is an immune cell in the brain. And in Parkinson's disease patients, that microglia, if you look down on the left-hand panel, it becomes thickened in the middle, not short branches, not as highly branched. And you can see after the prebiotic treatment, or these were prebiotic treatments mixtures given to young mice, and then as they matured, you can see that microglia health was maintained in this, what's called an azo knockout, that has Parkinson's disease-like symptoms. So it's pretty neat, and it related to improvements in motor movement and things like that. Okay, finally, last slide is a note on gut microbiota diversity. We just, Thaisa Cantu-Jungles, who I meant to mention on the first slide. She's research partner I brought in from Brazil. That's that Brazil Amazon connection. As a PhD student, but she has been with me for like 4 or 5 years as a postdoc, too long as a postdoc, and then this year she's a research assistant professor in the department, and published this paper on diversity, because you think that, you give fiber, diversity should increase, but that's really not usually the case. If you're giving single fibers and you're looking for an improvement in diversity, you're not likely to see it. The reason is because, and this is what when we talk about diversity, we're talking about alpha diversity. Not going to get into any definitions, but it's composed of 2 factors: richness, which is number of bacterial species, and evenness, which is abundance of species. Well, if you give 1 fiber or even a couple fibers in a in vivo study, animal, human study, or even in vitro, you're going to see a disruption of evenness. Evenness, that calculated value for evenness is going to go down. And even sometimes richness, you can lose sight of some species because they're, and some of them are promoted, other species are promoted so much that some go down in the level that below what we cut off as the detection level. So a lot of times, just to say, diversity can go down in studies on single fibers or perhaps even a couple fibers. Okay, opportunities out there on the horizon are fibers for targeted, predicted, common response across individuals, mixtures of fibers aligned with microbial groups. I don't think you even have to do, it could be approached in a more simple way, let me put that, than we did, to support the core community and promote overall health. Blends of fibers designed to support marginalized bacterial groups with specific disease states, even with potential towards treatment and prevention. That's really out there. And I don't say anything related to regulation on any of these, but and from the material side, something I didn't get into, but the use of processing techniques to improve fiber function in the gut. That's something that we have done research on and published, and others have too. And there's something real there. If you can take a very condensed kind of cell wall matrix and kind of explode it out and make it more accessible, even not make it soluble, you can target it towards certain beneficial groups of bacteria. Thank you. I'm happy to take questions.
Thank you very much for that. So we have a couple of questions here. The first is a bit specific, so I'll go slow. Do different linkage types yield differing human physiologic effects? I think you started talking about this, but can we get even maybe more specific? We have GOS that can be made from beta-galactosidase enzymes that are derived from different bacterial sources. And the result is you end up with GOS that has different linkage types between the sugars. So what implications does that have on the physiologic effects of the GOS made by different means?
Yeah, so it's a good question, and I don't think anybody would have like the definitive answer to that, but can say just a few quick words, because there's one side of it which is short chain fatty acids, right? And it could be that kind of targeted effect for a GOS structure towards a particular bacteria, which would probably be bifidobacteria, I would imagine, might be related, might at the mucosal layer, or lactobacillus at the mucosal layer, might improve the health of that mucosal layer through production of short chain fatty acids, specific ones. But the other thing, which is more vague, but I think is still out there, is that, you know, there's the benefit from short chain fatty acids. There's also the benefit that some groups are studying and have studied related to ecosystem stability and even their particular relationship with low inflammatory environments, like Faecalibacterium prausnitzii is a good example of that.
Okay. You showed data from humans, you showed in vitro, and you showed animals. And this is more philosophical, but given the really big differences between the microbiome of humans and animals, and including things like the fact that some animals eat their own feces, is this a case where the in vitro models might actually be more relevant than animal models when you're looking at the potential of fiber to have a beneficial effect on the microbiome?
Yeah, it's an excellent question. And I've heard people talking about it. We've talked about that very point with others. So, you know, I think that in vitro assays, of course, using human fecal material, they do have some advantages, but of course, you always have to go to the in vivo. And one wants to find not just microbiota changes, as have been mentioned by others, but health related changes, physiological changes too. But at the in vitro level, you can with regular human gut microbiota, you can see what the short chain fatty acid output is, even perhaps better than in the body, because in the human study, because most of those short chain fatty acids are absorbed, right? Like Cummings years ago showed like 95% are absorbed into the body. So I think there's a utility, a use for both of those. We do think now, we've done some animal studies also in this area, mice studies, but I think really if you can go to humans from the in vitro, that's the way to go.
Yeah, so the animal is a little less of an important step when it comes to this. Have you seen any effects of functional groups? And the example given was charged and uncharged on fiber's effect on the fermentation properties.
Yeah, we've not done that, but I know some groups that have at Nebraska. Devin Rose's group has studied that with pectin methylation versus, charged versus uncharged. And he has seen differences in the response then, both short chain fatty acids and of course, that would be related to microbiota changes. So I think there's something there. It's not that well studied though.
Okay. And does fiber or prebiotic specifically consumption help people who have small intestinal bacterial overgrowth? Any evidence for that?
Yeah, I don't know the answer to that, but an interesting paper came out a couple years ago, kind of posing the question, and with I think some data backing it up, whether oligosaccharides, like really easy to use kind of fibers are not that bacteria in the distal small intestine. I mean, there's bacteria that exists there anyway, right? But perhaps overgrowth of those bacteria, that they adapt to use those kind of fast fermenting, easy to access fibers that may, I don't know if one takes that logically to the next step, that may promote, you know, overgrowth a little bit. I don't know. But then but fibers that are more complex, like intrinsic fibers and cell wall matrices and all, may really push fermentation more into the colon. That would be my thinking anyway.
Okay. So your Parkinson research was really interesting. And one of the things that stood out to me linking to fiber is the gut permeability. And I wondered, is there evidence that gut permeability is causally related either to the risk of getting Parkinson's or in the progression of Parkinson?
It's there in Parkinson's disease patients, as well as dysbiosis in the gut. That's well established now, but I don't know. I really don't know, Barbara. I think it's more of an association than causative.
Got it. Okay. So you were measuring it to kind of see what the fiber was doing, but it wasn't necessarily on the causal pathway to influence, right? Okay. All right. And then do you envision a near-term or even mid-near-term future in which personalized medicine would prescribe a fiber mixture for an individual that specifically increases gut bacteria that are associated causally with whatever the outcome is that the treating healthcare practitioner is aiming for? Is this really the area of like personalized nutrition as a high potential, or are you thinking this is more of groups of people? Like if you've got Parkinson's, you could maybe see this, but how much of it is group versus personalized?
Yeah, I think that it's a real possibility in the coming years and maybe not that far out. I see it in two ways. I see that there could be, you know, there could be particular mixtures that would be more efficacious, if you will, towards a particular group that, you know, where they need, like the Parkinson's, we can use that as an example. But also, and even at the individual level, I guess there's a possibility, of course, there's a lot of work in this area going on now, but it's still not to this point, right? On personalized approaches, like at the individual level, you know, assessing microbiota and then, okay, you need this kind of fiber. I think there's an opportunity there and possibility, but also like we're intrigued with the idea that you can make mixtures of fibers with these kind of specificity idea that we've proposed that can affect populations, that can have an effect across individuals, but still may be more specific to certain health conditions or disease states.
Yeah, and this kind of comes to our final question for you. I think it's a good wrap up, is when you're looking to use a dietary fiber to make a targeted and predicted shift of the gut microbiome, what targets today are we looking for? In other words, how do you define that you've actually made an improvement to the gut microbiome or micro communities?
Yeah, I mean, in our minds, I mean, it has to go in vivo, right? And then it would be inflammation and barrier function is what we and our partners, you know, are kind of focused on. But I mean, immediately focused on, unless it's like I mean, we're interested in other outcomes, right? Health outcomes, but at the level of the gut microbiome, that's what we're interested in. I don't know if that answered your question well.
Okay, let me just ask you again. You said inflammation and what was it, gut permeability? Were those the two?
Yeah, that's right.
Okay. All right. So that's what I have for this. There are a couple of questions that I'm still carrying over to the panel. We'll get back to prebiotics when we get to the panel and talk about what's new with prebiotics and We also have a question from a paleontologist, so hang on, because I think that one's going to be a really interesting way for us as nutrition people to think a little differently. And so I always appreciate when you get things that make you think. With that, we now have Nicola McKeown, and she will be, that presentation will be followed by Hannah Holscher. And in both cases, these are practical tools because we're really trying to make this a very practical presentation for those of you who are on the front lines and have to make decisions. What is out there for you to now use in decision making? And the first of these will be the fiber database. And that is ready to roll. So here we go.
Oh, well, thank you. So many thanks to IFNS and IFT for inviting me to participate in this seminar series. My name is Nicola McKeown, and I'm a research professor in nutrition epidemiology at the Sargent College of Health and Rehabilitation Sciences at Boston University. So over the next 20 minutes, I'll provide you with an overview of a comprehensive fiber database that my research team and I developed. I'll give you an overview, some background on why we decided it was important to develop, what data that it houses, and then go on to talk about how you can access the database, some of the applications, and also end with some considerations in terms of using the database, what you would need to consider. So dietary fiber, as we know, is not a single entity. It's a broad category of compounds, historically defined as partially or completely indigestible plant-based carbohydrate and lignin. So today, we can meet our dietary fiber recommendations not only by from our food we eat, but also from synthetic or purified fibers in the form of supplements, or from individual isolated fibers, or enriched ingredients such as oat bran, psyllium, or different types of fiber enriched breads. When thinking about fiber, the complexity by which we classify fiber needs to be considered. And as you can see from this illustration, which is from our publication in 2016, there are multiple ways that you can classify or group fiber. So in this example here, fiber can be classified based on the broad, physically related compounds such as the non-starch polysaccharides, but you could imagine that this level could also reflect resistant starches at a higher level, and or the inulin type fructans, for example. And then underneath this, fiber can be classified and assigned into subgroups of physically related compounds, or later described at level 4 based on food sources, so whether they're from legumes or cereals. So there's multiple ways we can think about classifying fibers. And I think this slide illustrates the complexity of those classifications. In addition to the huge number of different ways to classify fibers and different fiber types, we also know that the research on the health benefits of these fibers continues to grow, with an average of 50 publications a year, as shown in this slide. And so one important feature to note about this graph is that this is only actually capturing the number of dietary intervention studies on fiber, so not studies that are conducted in animals or observational studies. And so you can see that within this field, it continues to steadily increase and grow. And as an example of how the research field is continually evolving and changing, this image that was created, this data visualization created by Dr. Larry Parnell at the Nutrition Research Center on Aging, is showing how he, by downloading the database, was able to characterize and look at the different fiber types linked to different aspects of gut health. And as you can see, the colors here reflect different fiber types. And so, for example, you can see the research on inulin and oligosaccharides is continuing to increase with the oligosaccharides. So basically, this is a nice example of a data visualization, a data that you can create from accessing the database. So with this background in mind, the fact that fiber research is complex, you can see why there was a recognized need for a centralized resource that would house the research. And so with funding from IFNS, my research team and I developed a publicly available comprehensive database linking fiber intake in humans to physiological health outcomes. The overall goal of the database was to, as I alluded to, establish a comprehensive database designed as a foundational resource for human studies connecting fibers to health-related outcomes. And so this database aims to really streamline the process for researchers, policymakers, and food industry scientists, allowing and facilitating the efficient identification of fibers of interest. So we started this project in 2013, and the first version of the database was published in 2015. And at that time, we extracted data from nearly 900 papers. Since then, we have been consistently updating the database, originally publishing a new version annually, but more recently we've switched to frequent updates every quarter. And today we have extracted over 1,300 published human intervention studies that will be found in our version 9.2. To give you a brief background on the creation of the database, much like you do with the first steps of a systematic review, we created a set of search criteria, and at the time, 2015, decided to restrict that to a Medline search, in part because of the vast number of papers that we were identifying. And based on that Medline search, where we identified almost 12,000 papers, we also then went on to refine some of our exclusion criteria, and so ended up with, as mentioned, with 900 papers. Just to let you know, in terms of inclusion, we originally started with adults, but we've now, since I think version 5, included data for children. So we updated the database to include data from children. And in the interest of time, I'm going to go through each of the exclusion criteria, but they're here for you to review after the talk. So in terms of what we extracted, the database was designed with extracting PICO information. And so typical PICO, which is your population, intervention, comparator, and outcome, data would be, for example, population, some information on age, gender, BMI, health status, and other characteristics with respect to the intervention, the fiber type, dose, duration, and how it was administered were key criteria that we want to capture. The comparator aligned with the intervention in terms of what we captured, and then the outcomes of interest were the Vivuni outcomes. And just to recap on what they are, they included total and LDL cholesterol, postprandial glucose and insulin, blood pressure, increased fecal bulk annexation, transit time, colonic fermentation, short chain fatty acid production, the modulation of the colonic microflora, weight loss, weight maintenance, and reduction in adiposity, any data on increased satiety, and bone health. And so while these were, oh, and sorry, I should point out that later on, this was not a Vivuni outcome, but we also then expanded the database to include outcomes related to bone. And so while we have these as our broad categories, we did extract, data, we did indicate whether other lipid measures were available and other glucose and insulin measures were available. So there's a number of additional outcomes that are characterized in the database. So now that you know what is captured in the database, how can you access this? And so you can go to the IFNS their homepage. I have also included the actual link here for the landing page for the fiber database, but this is where you'll find the database housed on the IFN website. And once you click on the database link, what you can expect to see is that there are a number of resources that are available. The first being, the database, a link to the database, a link then to the user manual. The user manual is updated along with the database. So any changes that have been made or anything you feel that the user needs to know, or how any changes may affect earlier versions that you might have downloaded, would all be documented in the user manual. There is a summary sheet that gives you the database overview. We are continuing to populate this link with publications that are using the database. So if you do use the database, please let us know and we'll include your publication here. It's important for us to cite the use of the database. And then there's a brief, a description here on rational methods, which were derived from our 2016 paper. So once you access the database, you'll be asked a number of questions. We'd like to continue to find out who's using the database and for what purposes. You'll be asked to sign up by provide your email for us to notify you when the database is updated. And then you have the option, to download the entire database in two forms. One where the descriptive labels are in full, and then an Excel database where the labels are shorter, which allows for versatility in using the data with different statistical software. But not everybody will necessarily want to download the full database. Here you could, for example, like I have used the database just to search in a PMID, and I'll show you what information that would provide. But you could do a crosstab between, fiber type of interest and outcome. And once you select or put in your search here, oh, I'm sorry. I just want to first show you basically here, sorry, the database that is downloaded in Excel. You can see here some of the labels. And to let you know that, yes, we've actually, while it's downloaded in an Excel spreadsheet, we have used different formats and used for more sophisticated tasks, such as grouping similar fibers and outcomes or conducting actual analysis. We find it more efficient to use SAS or R. And so please do reach out to us if you end up downloading the database and you want to utilize those packages. We may have code available that we could share. So just to go back to the point that I was making, that for some users, they'll not be so interested in downloading the entire database, but may, for example, want to focus on a particular fiber. And so what is nice about accessing the database this way is that we have this searchable interface. And as I mentioned, you can put in your fiber type, you could do a cross tab with an outcome. Here, I'm just going to walk through an example of if you're interested in soluble corn fiber, for example, you would put that in and run the search. And what you would get in terms of output, again, it gives you the option to download data. But here you can see that there are a number of papers that had soluble corn fiber, 14 in total. And this feature allows you to order by year. So you can see here the publication year. Then you have this option of viewing the details. And once you select the view details, at a glance, this is what you would be able to see with respect to this paper. So in this case, this is a publication that came out in 2020, the country where it was originated from, the type of study design. There's a series of study design questions. Was it blinded? What type of diet was provided? Were all the foods provided? The level of the intervention, provides information on sample size, and then a series of other questions that characterize the study population, the age, the BMI, the range. And then it'll inform you what outcomes are the broad groups. So in this case, it's glucose, the postprandial, and it identifies that as the Bahuni outcome. And so you can find out just by searching on a PMID or fiber of interest, some information on paper. We've also now in our next version going to provide the DOI link. So that will bring you directly to the manuscript or the publication if that's of interest to you to go straight to there. So I'm going to wrap up now sharing just some of the applications of the database, some examples, and then touch upon some of the considerations if you want to utilize this database, what you might want to consider. So we have in our research group used the database to conduct evidence-based reviews and meta-analysis. So it's a very useful starting point for anyone who is going to conduct an evidence-based review in particular fiber or fiber-related outcomes of interest. But it can also be used as a useful tool to help stakeholders understand how different fibers are characterized in research studies. In addition, it can be used just as product developers to identify what is currently out there in terms of the literature, what research is being conducted on a specific fiber ingredient. To end with some considerations, as I mentioned earlier, the search strategy was restricted to the Medline. And so you may want to consider searching secondary sources, depending on what the objective of your study is or why you're utilizing the database. The database does not assess study quality. It does not extract actual data. And so if you are moving forward with a meta-analysis, these are two elements that you would need to consider. While the majority of the studies do capture the isolated effects of fibers, some studies may be confounded by other attributes of foods, such as the glycemic index. So again, when you're conducting your own search strategy and looking at the data, considering these types of attributes of the food are important, depending on your objective. It is limited to just the 10 health outcomes, so depending again on your objective, you may need to conduct additional searches. And as I said earlier, it does not incorporate the results or the direction of the evidence. There are a number of strengths to this database. Obviously, the flexibility is one, and the searchable interface that I talked about makes it very usable for graduate students, and stakeholders, as well as researchers, but that feature itself is very flexible. It allows you to create visualizations on a body of literature, which you can then update annually as you download the most recent versions of the database. As I mentioned, we're now updating it. We switch from annual to quarterly, but we think the sweet spot will be updating this twice a year. So moving forward, we'll be uploading a new version every 6 months. And as the user, this would be a very cost and time efficient way for you to get up to speed on a particular particular health benefits of a diet for fiber. So with that, I would just like to thank you for your time. I'd like to thank IFNS for the funding and outreach, and thanks to many of the students and team members who worked on this, both the initial build and then the maintenance of the database, and to my managers, Cara and Betsy, for helping with that aspect of the project. And please do reach out if you have any questions. We're happy to help and provide any support that we can when it comes to utilizing the database. So with that, I thank you all for your attention, and I look forward to your questions.
Well, that was a mostly audible, somewhat visual summary of the tool. And I say that being very grateful to Nicola, who recorded that when she was starting to feel ill and got that recorded ahead of time. She is not here with us, so we couldn't adjust the either the audio or the visual on it, but here's the good news. My last slide is going to show you an email, Gwendolyn@ifns.org, that you can write to, and we will share slides with you. It's also a place that I'll let you know you can get a link to our YouTube channel that'll host the whole webinar, but that's not going to help you much because it's the same audio and visual. So we'll, if you want that, just write to us at Gwendolyn@ifns.org and we'll get you that presentation. And also, Sydney is going to post in the chat a little bit more on this, but you're going to get, after the webinar, a link to the IFT's learning portal, and we'll see what we can do to get slides up there as well. So that's the first good news. The second good news is that we have Kara Livingston, staff here with us, and she's going to address any questions that you might have about the database tool. She's worked with Nicola from the beginning and throughout on this, so a real partner with Nicola, and I have her with. I don't have any questions showing in my Q&A right now, so what I'm going to do is just turn it over to Kara and just ask her if she wants to comment on anything in particular, given it was a little hard to probably track what was going on. So over to you, Kara, for a couple of minutes, and we'll see if any questions come in.
Yeah, sure. I think in my eyes, the best part of this database is that it's just really versatile. You can just search it and use it for what it is, as a way to find the evidence and look at the data that's been extracted, or you can download it and you can kind of start your own version from it. Like, you can add to it your own variables if you're doing a systematic review or just any type of project. It's in an Excel, so you can modify it, add it, work with it. You can bring it into statistical software packages like SAS or R, which is what we typically do when we're doing analyses with it. And it's, now, at first it wasn't like this when the database first began, but now it's become, through the IFNS website, searchable. As Nicola showed in the screen, you can type in a specific fiber and or outcome, and it'll pull the subset of papers. So I think it's just, hopefully for everyone, a really easy to use, accessible resource. And the other thing I'll mention is it would be great if people are using the database, if they could share with us who they are and what they're using it for. I think that's something that we've always been really interested to know. So now there's that area, I think it was on the slide and on the IFNS page, where you can submit your name, or you can always just email Nicola or I too, and just let us know, because it really helps to know who the audience is as we grow this and continue to develop it and everything.
Yeah, I'll just add to this too, having worked for many years with people who were ingredient experts in a company and even nutrition experts in a company, there's two ways you might be interested in. You might be asking yourself, well, what fiber could I use if I want to get this certain outcome? And so you can search the database by health outcome, and it'll give you all the fibers that have been tested in human clinical trials in peer-reviewed journals. And then the second way is you might be working with a fiber and wonder, well, how good is the evidence, or how mixed is the evidence? And this gets you the pile of papers that have been done on human trials on that fiber. And you can even then again sort it and maybe only look at certain health outcomes for that fiber if that's what you're interested in. And so once you have that pile of papers, then you can evaluate your data yourself. I mean, that's not the job of the database. The database is to get you to the right pile of papers, however you want to sort it. You can even limit it by age or time frame, right? So there's lots of ways you can use the tool. And it's probably best to just go in and experiment with it and see how it might be useful to you in order to know how it applies to your job.
And there's also, with it on the IFNS website, there's a pretty detailed user manual. It has all the variables that are in the database. It has a history of how the database was developed, the process, and kind of the different versions of the database and what's included. So that's great context to anyone who wants to use it, just to understand how it got to where it is now, and what's in it, if you really just want to.
Well, I think we have some more East Coast weather, freezing Kara.
Oh, did I freeze?
Yes, you did.
Oh, sorry. Yeah, I don't know how much of it you caught, but I was just mentioning that the user manual is available on the IFNS website. And it has a detailed kind of history of the database, how it was developed, the different versions, and then also it has a detail of every single variable in it and the different answer choices that we use when extracting the data and everything. So it's just a great resource to kind of get familiar with the database.
Great. All right. And Kara, are you planning to be back during the panel in case people have additional questions?
Yes, I can be.
Okay. All right. So if anyone has any additional questions, you pop it open or something and take a look at it here as we're moving towards our final panel discussion. You are welcome to post more questions and Kara will return for that. At this point, we are going to turn this over to the second topic of tools for your use with Hannah Holscher. So over to you, Hannah.
All right, excellent. Can you hear me okay?
It is great.
All right, wonderful. Well, I hope everyone has been enjoying this session as much as I have. I've been working in the fiber area for about 20 years now, if I include my doctoral studies and my time working as a registered dietitian. And I am learning a lot in this area because fiber is so fascinating and it's an expanding area. So a little bit more about me. My background is in nutrition. I am a registered dietitian and my PhD focused on gastrointestinal physiology, probiotics, and prebiotics. And then I did doctoral training focused on the human microbiome. And now I'm an associate professor at the University of Illinois. And my research program focuses on clinical and computational approaches to study the interactions between diet, the microbiome, and health. The hat I'm going to wear today, though, is really focused on these clinical applications and thinking about designing clinical trials and some of the outcomes you really want to make sure that you're assessing with this focus on tolerance. So thinking about those gut feelings. So considerations for capturing tolerance to non-digestible carbohydrates, because Joanne really set the stage, right? If an individual consumes a certain fiber and they can't tolerate it, they're not going to go back to it. And so certainly for those of us looking to help improve human health, we have to consider that. And when I wear the registered dietitian lens, I certainly have to consider that because again, if I'm recommending a food for someone to consider, it has to be something that they can tolerate. So as we design these novel fibers, and I love seeing that research coming forward, we have to be considering capturing tolerance. So to start with, my disclosures, I am a University of Illinois employee. I've listed all of the grant support that I have current and past over the last 2 years, some of the speaking honoraria that I received from different food companies, and then consulting and advisory boards. The content of this presentation is solely at my discretion, though, and those opinions presented are my own. What I'm going to be going through in this presentation is first the thinking about tolerance to non-digested carbohydrates and dietary fiber, because again, this is going to matter to patients and consumers. They want foods that taste good and don't cause them ill effects. And there is going to be a range of tolerance for that. And when I present these data as we move a little bit forward, please do keep that in mind that some of these values and figures are going to be an aggregate. You'll have some individuals that can't even look at a fiber bar without having ill effects like flatulence, but other individuals can eat 3 of them and don't even blink an eye. So do keep that in mind if some of you coming from certain fiber companies are heavily involved in certain fibers feel that maybe we are being too conservative in the recommendations for fiber tolerance levels. Do keep that in mind when we see those. So some considerations for assessing tolerance and really focusing in on some of these tools and resources for assessing tolerance with a focus on a perspective paper that a group of us put out right at the end of 2022. So let's define tolerance. Tolerance is self-reporting of various gastrointestinal symptoms. So this figure here is showing gastrointestinal effects. On the left, there are objective effects, and then on the right, there are subjective effects. When we think about tolerance, it's really those subjective self-report symptoms that we're focusing on. It's not the objective measures that we can do. we can measure gas production. We have some sophisticated techniques now that can actually see how much gas is produced from a certain fiber. But because different individuals will have different responses in pain based on how much gas is produced from consuming a certain fiber, we have to rely on the subjective questionnaires for this, because that is going to underlie this definition of tolerance. So for tolerance, we can certainly use the objective measures, but we must incorporate these subjective symptoms. And that was really one of the key conclusions of the paper that I'll talk more about here. But one of the resources I'm going to be talking about first is this review that my grad student at the time, Anne-Marie Meisenheimer, did on gastrointestinal effects and tolerance to non-digested carbohydrate consumption. This is an open access publication. The open access fee was supported by IFNS, and it goes through a summary of all of the fibers that at the time were all of the non-digested carbohydrates that are accepted as fibers by the FDA, what the range of tolerance symptoms were for those. So I'll just very briefly go through those as one of the resources here. So let me hide this actually. I think it might be, there we go. Might be creating a black box. All right, so as has been alluded to by the other speakers, fiber is an umbrella term. They're very heterogeneous. They have different physical chemical properties, their solubility, their viscosity, and their fermentability. You can have lots of different fibers that can fit under different categories. They'll even bridge areas in between. And it is important to keep these characterizations in mind when considering tolerance, because they will contribute to some of those factors. So take, for example, the solubility and viscosity. For this, the molecular weight of those and their viscosity will affect the amount of water that gets drawn within the gastrointestinal tract. So if we think about these non-digestible carbohydrates and fibers, those molecular weights, their branch linkages, and these physical chemical properties, solubility and viscosity, will affect how much water gets drawn into the colon as these components move through the gastrointestinal tract. And so that will certainly influence the softness of the stool. It can also affect the rate of transit that it moves through the gastrointestinal tract. One of the other components that is certainly going to be relevant is the fermentability. And this is where we're thinking about the microbes that are present. And you can have personalized responses for the microbiota, and certainly this will affect the degree of fermentability of certain fibers. But one of the components that will come into play is that when the microbes break down the non-digestible carbohydrates, some of them will produce gases. And certain individuals are more prone to sensing pain when there are even mild amounts of gas that are produced from the fermentation of these fibers. So these are where those physical chemical properties will underlie some of the factors that affect tolerance. So again, there is a range of tolerance for the intakes of non-digestible carbohydrates. What I'm showing here, the legend on the upper left, are the different categories. So I'll show you the soluble, viscous, fermentable fibers, such as alginate and gar gum. Then you've got soluble, viscous, non-fermentable psyllium. And then you have soluble, non-viscous, fermentable fibers, soluble and insoluble, and then resistant starch. So again, realizing these are going to be umbrella terms even within these particular ones. The y-axis is the non-digestible carbohydrate intake gram. And these are the amounts that, based on our review of the literature, that individuals can consume these non-digestible dietary carbohydrates and only experience mild symptoms. So only very mild gas or bloating. Now, again, these are conservative recommendations. And this is where I was saying, if some of you feel that, yeah, your fiber or particular fiber has been shown to be able to be consumed at much higher amounts than what I'm showing in this figure, I certainly acknowledge that. Some of these fibers have been studied from 5 to 50 grams, and individuals can tolerate those. But when you get to higher amounts, when you use this paper that I've referenced at the bottom as a tool, you'll start to see where, let's take inulin, for example, right in the middle, you'll start to experience mild symptoms of gas and bloating at about 5 grams. But some individuals may only experience moderate symptoms up into 10 to 20 grams. So they may be able to tolerate that quite well and start to have those health benefits. So again, these are the conservative recommendations. When you're thinking about formulating a product, this would be relevant because if there are levels where individuals start to experience intolerant symptoms like gas and bloating, you wouldn't want to make one bar that has 10 grams of a fiber that some individuals will start to experience symptoms at 4 or 5 grams. So a tool that you can reference to help keep that in mind. So one of the other papers that we put forth for this was really focused on translating this information to dietitians. And so for this one, what I'm going to be showing you are these non-digestible carbohydrates and some of the reported health benefits and what those therapeutic doses were, meaning for alginate shown here, doses of between 1.5 to 8 grams have been shown to reduce postprandial glucose. So all of those studies showed a reduction in postprandial glucose. Very mild symptoms would start to be noticed at 3.7 grams of alginate. But again, some individuals can tolerate more quite well. But if some individuals may not get that health benefit until upwards of 8 grams. So again, balancing this tolerance and the therapeutic doses is going to be really important, especially when these ranges start to vary a lot more. So we can see here, gargum has shown to reduce blood cholesterol, the therapeutic doses and tolerable intake levels there. Psyllium husk, inulin, FOS and oligofructose with increase in mineral absorption, polydextrose, GOS, soy fiber, and resistant starch. And so I'll let you take a second here to just take a look at comparing some of these therapeutic doses to tolerable intake levels. So again, the take home here is that as you're developing different fiber formulations, some individuals can experience mild tolerable intolerant symptoms like gas and bloating at the levels shown on the right. And then the studies that have been done to show these health benefits, those are the ranges that they've been done. So again, in some cases, the ranges will overlap quite well. In others, there might be a bit of a disconnect. So keeping that in mind. All right, so what I want to spend the bulk of the rest of our time together is really focusing in on this tool, which is a perspective paper that a group of us were published in late 2022. And what we sought out to do was develop a protocol and provide tools for individuals that would be conducting clinical trials to assess consumption of non-digestible dietary carbohydrates. And so we really wanted to encourage everyone to measure tolerance in any study that is doing research on any of these non-digestible carbohydrates, because even if it's not your primary outcome, it is very useful information for others to be able to utilize so that we can continue to build this research area. To ultimately address what Joanne was talking about in the beginning is address this significant fiber gap where less than 10% of individuals are consuming adequate fiber. So what were some of our main conclusions? Firstly, we had recommendations for a number of areas, measures. So firstly, thinking about when to do these measures, and that would be to capture baseline symptoms before acute challenges, during a lead-in, measuring symptoms for at least 48 hours for acute studies. For acclimation studies, about 2 weeks is kind of the minimum you'd be looking at there, and making sure there are adequate washout periods that in general need to be approximately the same length as the intervention, especially if you're measuring the microbiota. For the intervention, a few of the things that we highlight that were really important are fully reporting the characterization of these non-digestible carbohydrates and how they're consumed. Were they incorporated within a food or a beverage? Thinking very carefully about what your negative and positive controls are. And so please use this paper as a tool because we have very specific and detailed sections that spell this out in much more detail. The population. Considerations for all of the factors that will influence how an individual responds to these fibers. So their age, their health, diet, lifestyle, medications, again, a range of things that you'll want to keep in mind for establishing your inclusion and exclusion criteria. And then the outcomes. Again, one of the most important things that I really want to stress here when we think about tolerance is that it is the subjective participant reported symptoms that need to be assessed via standard gastrointestinal questionnaires as a primary tolerance outcome. Objective outcomes are wonderful and would certainly encourage you to include those whenever possible, but they cannot replace those subjective questionnaires, because again, it goes back to that example I used in the beginning, where if we just excuse me, if we just objectively assess gas production within the colon, that doesn't tell us what the pain perception is for some of these individuals. And again, some individuals with even just mild gas production have very significant symptoms. So it is important to assess that range of subjective symptoms. So in the publication, again, this is an open access publication, and we have supplemental materials that you can easily download that have some examples of standardized gastrointestinal questionnaires. And when I'm just showing some screenshots of those for you here. So you can do short term. So over the past 24 hours, you can indicate the severity of factors: burping, cramping, distension, bloating, gas and flatulence, nausea, heartburn, rumblings. Some of the other tools that are included are, again, thinking about the bowel movements and ranking those. So asking individuals, did you have a bowel movement today? Yes or no? And then carefully educating them on how to complete these tables. When was the bowel movement? What was its consistency? Using the Bristol stool chart. And what was the ease of passage? So that consistency, they'd be having a physical picture of the Bristol stool chart that they could reference so that they can check, was it type 1 with those hard separate lumps, or was it more in that normal range, 3 to 4, or was an individual experiencing diarrhea? Because again, we do need to assess stool consistency, because with certain fibers, they at very high doses, there are instances where they can cause diarrhea. And so being able to capture that information is absolutely integral. The ease of passage is, again, really getting back to that subjective state for how did the individual feel after that bowel movement. Another thing that my laboratory does, just as an aside, is we will also make note, the scientists that process the stool samples, because we collect full stool samples without the participants manipulating them in any ways when we use the stool commodes. So our scientists will also mark down the Bristol stool, and we will do comparisons. And in general, those values are fairly similar between what the participant marks down and what we do. You can also use 7-day questionnaires. So again, this was a standard questionnaire that has been used in the literature. It was originally published in this Mackey paper. So you can download the full questionnaire there. So this asks very similar questions for nausea, rumbling, gas, bloating, etc. But they ask the participant to think back over the last 7 days. So these are the weekly questionnaires. Did they have it? Yes or no? If yes, then they'll simply mark no more than usual, somewhat more than usual, or much more than usual. And in some of the studies we've done on the fibers, we will frequently utilize both the daily questionnaires and the weekly questionnaires, so that excuse me, it is cold and cold season, so that we can look at that information in aggregate. Last tool that I want to highlight before I wrap up here in the next minute is this tolerance assessment tools. There are also validated tools that are available, the gastrointestinal symptom rating scale, which we talk about in the perspective paper in Advances in Nutrition. This is a validated tool. It queries symptoms over the past week, but it was developed as disease specific. There are values for the general population, and again, it has been used in adults consuming non-digestible carbohydrates, and you can see some of the references down below. So with that, I hope what you've taken away from this is that non-digested dietary carbohydrates will differentially affect tolerance. Factors like their physicochemical properties will play a role, and the individual perception. Ultimately, though, take home, it is vital to assess tolerance when doing studies in this area. And I hope that you found it useful, and we'll flag those references so that you can download those tools with these standard questionnaires as well as the validated questionnaires, so that you and scientists that you work with can utilize those for your future studies. So thanks so much for your time and attention. I'm really looking forward to the discussion.
Thank you, Hannah. We're covering all the coasts. Hannah's out on the West Coast. I'm sitting in the middle in sort of, we're confused weather. We were supposed to be snow, but we're just rain. And then we've got the East Coast team that's holding off the, I don't know, tropical storm. So thank you, Hannah, for coming in early. All right, so a few questions for you before we move to the full panel. I've had the privilege of working with people who had to make decisions on what fiber to use based on the application, the cost, the benefit to the consumer, the interest of the consumer. And one of the hardest things we had to deal with is trying to decide, you know, this one versus that one versus this other one, right? And so I wondered if we don't always have really good data on gram for gram exactly the same, you know, 3 grams of this one and 3 grams of that one, is it fair to take the dose data that is available on tolerance of these fibers, graph them out, and then just use those lines to do a comparison and find the one that you're going to be able to do that has the least symptoms, detectable, perceivable symptoms by the consumer? Or can't you do that kind of thing? Do you actually have to test gram for gram in a side by side?
I guess so. Opinions could vary on this, but sorry, in the sunlight's, as you said, the different time of day, the sunlight's coming through odd here. Ultimately, my opinion would be it depends on what your objective is on that study. If, for example, you are interested in providing the fiber for a benefit on laxation, and you utilize the available data and know that fiber A has to be consumed at 12 grams to be able to provide a laxative effect, but it has intolerance symptoms beginning at 5 grams, it would be important to also consider, you know, is there a different fiber that I may need to provide at 20 grams to be able to have that laxative effect, but have no intolerance symptoms? So it's not a very direct question in that regard for matching the gram per gram. That wouldn't be as important to me as what the primary outcome is. Okay. I would certainly keep tolerance in mind because, again, if there's consistent data that this fiber over 10 grams is going to be intolerable for the vast majority of my participants, I'm probably not going to have that one as one of my options. So I would take kind of this matrix of factors in consideration when designing those trials.
So that leads to the next question. You had a nice slide that talked about the dose that is effective, and then the side by side you had the dose that had some sort of perceivable effect on consumers. Were those dosages age and gender specific in your paper? And if not, is that data available or?
Yeah, so that's a great question. So again, that paper with the table was published in Nutrition Today, which is very focused on dietitians. And so the column with the tolerance data was based on the systematic review that Anne-Marie conducted on about, I think there were 160 papers. And we used Nicola's tool that they were talking about in Kara's as one of the starting places for that. And so we did base that on healthy populations. And so they wouldn't be having diabetes, for example, for those glycemic responses for our tolerance intake data. But that middle column with the health benefits, that was to compare the data that had shown health benefits. And so that may have been in populations where they had hypercholesterolemia or type 2 diabetes, where those therapeutic doses. So the therapeutic doses column and the tolerable intake column in that table are not all within the same studies, if that makes sense. So that's more of a conglomeration of the available evidence. And so you would want to use, you know, our papers as tools, and then also the database that Kara and Nicola were talking about to help to do a deeper dive to better understand how those compare for each of the individual non-digestible carbohydrates.
So let's just talk about the tolerability column for a second. So let's say that you found some papers on tolerability in adults. How would you use that to make decisions in adjusting the tolerability best guess for a product made for kids, for example?
The prospective paper that we published in Advances in Nutrition that Joanne was a member of, and on that, we actually had a pediatric gastroenterologist, Bruno, on that paper, who has an entire section with the considerations for children. And so he goes into a deeper dive for that when you're considering those products specifically developed for children. But in general, the values are likely going to need to be lower if you're just looking for, kind of a simple recommendation as you're formulating those. But there are also, for doing clinical trials in children, he also does point out a couple tools that are available for assessing things like Bristol stool and question and tolerance symptoms specific to symptoms, where they've got little faces that children can look at to be able to tell their caregiver, how they felt after consuming that product, for example. So again, that perspective paper that I had, the privilege to work on with the other scientists in that group really provides some key and comprehensive information for anyone moving forward with clinical trials to help them check all the boxes, because it's, what do we say to our grad students? We say a week in the library saves you a month in the lab. When you're developing these studies, just thinking about this very, very deeply and talking to lots of people is key, because clinical trials are really expensive to do and everyone tries their best to get them right. But talking to different people and considering different perspectives can really help make sure you don't overlook something like there is a validated questionnaire available for kids that can help you best assess those symptoms.
Mm-hmm. Yeah, I think most companies are probably not going to be contemplating a clinical trial to do this. They're going to have to make practical decisions based on data that's already available. So yeah, going to your paper might give them some clues as to, can you just adjust by body size? And I also just want to put a plug in that talking with that pediatrician, one of the things he reminded us is that complaints about bowel movements and lack of them is like one of the top reasons that people have kids in the pediatrician's office. And so, we shouldn't shy away from getting fiber into kids' products, but we do need to be thoughtful that they are in there in amounts that are meaningful from a health benefit and don't deter people from repeated use, which brings us to the next question, which is about habituation. So if tolerance can be improved over time, shock your system in the beginning, perhaps, and then work your way to happy, what did you call it? Gut feelings. What are we talking about here? Are we talking about days, months, weeks, you can't possibly get to the highest dose right away without just really throwing everything off? What's kind of the reasonable plan here for expectation and development?
Yeah, that's a great question. And I'll answer it two ways, with my dietitian hat on, kind of very patient focused, and then kind of my scientist hat with designing these clinical trials. And so with your, your patient focus, if you're sitting down and you're interacting with a client, doing something very practical and talking to them about, there may be this particular bar that they would like, that the registered dietitian has decided, done the research on and may want to recommend because it has certain fibers in it at high amounts. They may be telling them to do something like consume a quarter of the bar, see how you feel that day, and then move on if you have no symptoms to half the bar the next day or the full bar the next. Just kind of querying, have you had symptoms in the past? And if it's someone who's can eat large amounts of fiber when you're having a conversation with them and doesn't have effects, you may just say, yeah, this full bar should be well tolerated by you. I don't have any concerns, but if it does, back up. When we're doing the clinical trials, what we have done in the past is usually doing something like half of the dose on day one and the full dose on day two, or maybe even scaling it back a little bit longer, depending on, again, what is the fiber, what does the data show us about how tolerable it is, and expanding it out a little bit longer. But if you do look at the full body of literature, in general, habituation and acclimation, the most consistent is that within that first week and moving into that second week, you would start to see that acclimation of the symptoms. So once you get through that first week, and I believe, I'm trying to think which particular paper it was that really did a super nice job on this. I believe it was out of Glenn Gibson's group, but just even looking at the microbiota stabilization and habituation, the gas production, the symptoms, that 2-week acclimation period tends to be consistently shown to be kind of an aim for when you would want to do those measures. So during those last few days of a 2-week intervention period.
Okay, now let's talk a little bit about serving sizes, because people eat a few foods a day and they're of a certain serving size, and your dose column for benefit and your dose column for tolerance were really per day. So I'm trying to figure out, you know, if you think about how FDA thinks about health benefits, it's usually like 4 servings a day. So you could divide your therapeutic efficacy dose by 4, and per serving, 4 servings a day could be advice given, right?
Mm-hmm.
Then I get to the tolerance one and I go, yeah, but does tolerance actually, does it work that way? What if you did put all of that tolerance in a single serving versus out over 4? Is a single dose of the tolerance at one time different than that tolerance averaged out over the day?
So what we've done in our different studies, one example would be a fiber that we did at 0, 5, and 7.5 grams per day. And we had that in 3 chews per day. So they were like chocolate chews, essentially. And we did ask the participants to dose those out over the course of the day. But they could choose to eat all 3 of them at the same time, right? But ultimately, what we were capturing in their tolerance records was, did they consume all of the fibers? So, you know, collecting labels, querying them frequently, making sure they're consuming all of them each day, and looking at both the 24-hour data, but that's going to be an aggregate during that last week, and then also the 7-day questionnaires. So it's going to, the tolerance data, you would need to look at it very carefully and how it's reported in those papers. So this particular one that I'm talking about with the inulin, when we published that one in Food and Function a while back, I think it was probably 2015, you know, we did look at both the daily and then the weekly results, and that acclimation period was around that 2 weeks. By week 3, they were mostly stabilized, but again, it's just going to depend on how the data get reported, how you can make those conclusions. If the scientists don't give you the daily records of the tolerance data and they analyze the results in aggregate, you're going to be able to make different conclusions than if they give you the daily sequential data, so that you can see, oh, look, is day 5, they gave me every single day of this 21 day. By day 5, people were fine. But again, if you don't have all 21 days, you may just have to say, okay, it looks like by week 3 is when they're telling us they're okay.
Okay. While the rest of the panelists are getting online, I'm going to ask one last question. This is in the category of a pigs could fly, imagine. So I'm thinking about if gas production is one of the main tolerance symptoms, and I think about human digestion and how it's kind of averaged out over time. Is there any way to actually time the fiber intake so that gas production occurs while people are sleeping and not while they're awake? And while she's answering this, if Joanne, Paula, Bruce, and Kara, you can come back on, that'd be great. You can turn your videos on and be ready to unmute.
Yeah, I mean, certainly thinking about time and day would be important. With one of our studies where we did look at gas production, we looked at breath hydrogen production, and that was with an agave inulin, which is more branched, and we had that over 8 hours. But Joanne has done some really nice work with chicory inulins and done the breath gas production and shown kind of when those fermentation profiles will peak and when they hit, they start to subside. And you can get an idea for that greater branching. The peak started earlier, so around 5 hours for ours versus the chicory inulin. That's going to be around 8 hours when that was going to peak, and then it went back down. So you can make some presumptions about the timing of that fermentation based on the branch length, and could consider that in your recommendations for the timing that you're going to be recommending those in that regard. So, but if you were, you know, actually wanting to objectively measure that, the breath hydrogen is not very invasive, right? You're blowing in a tube, but if you're wanting to get it, you know, this actual flatulence measures, those are pretty invasive. And so having those individuals sleeping with, you know, anal tubes so that they can capture that gas, you know, how translational is that? Are those results actually going to be? So again, using the body of evidence, thinking both practically and from a scientific perspective, I think can be really important in that regard.
Okay. I'm not signing up for that study. All right. So I want to kick it off with one kind of question that we've had from the beginning that I saved to the end because I think multiple of you might have an input. So we had an evolutionary paleontologist ask us a question that's very kind of high order, which is, when we're increasing fiber, are we essentially recovering the benefits that have been lost as humans have moved from being mostly vegetarian to being omnivores? And let's not debate whether they started as vegetarians or were vegetarians during a certain part, but when they were vegetarians and moved to more omnivores, is that basically what we're doing, adding fiber? Or are we really trying to hack our biology, biohack it, in order to say, let's do better than what we might have done in terms of quality of life and longevity? So anyone who wants to start, just go ahead. If you just want to raise your hand or jump in, that'd be great.
I'll jump in, Barbara. To me, if I go back and look at what are humans meant to eat, we don't know that we were meant to be vegetarians, that we are omnivores whenever we can be. So I think that's one issue that I always get into. And what did we eat over time? We ate what was available to us. And as long as, we figured out whatever, the hunter-gatherers, whenever there was hunting, people were eating that. So I find that really difficult, especially if you can't isolate a community and have pretty good data. So it's kind of this history of the way we thought things were, and are we trying to get back to that? We don't know that that's the way things were. We really don't know that we're omnivores. So we're very similar to pigs that will eat anything we can get. And a lot of that is not plant-based at all. It's animal-based, it's fat-based. And what do we crave? We crave for fat. So if we can find butter anywhere, we're going for it. So I find that, and that's a hard thing to study just because we don't have great data on it. So I guess to me, it's we're not really trying to get back to those days because a lot of those high fiber compounds are not very nutritious. And we got into that discussion. That's hard to get the nutrients out of them, hard to get enough calories, especially in growing children. So I don't think that's a really good way to think that we need to get back to this time where people were on high plant food diets. I just think that fiber is a nutrient and we need to think of practical ways to deliver it to people that are in challenged positions that they won't be able to cook and get the foods they need.
Anyone else want to jump in?
Yeah, there was a really interesting paper. Now it's probably, I guess around 2010 or something, by a guy named Jim Leach in European Journal of Clinical Nutrition. He was a paleobotanist, and Joanne, I don't know how he arrived at this number, but I'm gonna say it anyway. The evidence in the paper was some, 5,500-year-old species, and omnivore or vegetarian anyway. It had a lot of fiber in it, coarse fibers, and he came up with kind of an estimate or guess, I guess, that man at that time, early man, was consuming like between 90 and 120, if I remember right, grams of fiber a day. And I think, well, maybe that's possible. It was a lot of, cell wall, materials, or plant materials. And, you can think even if it, 30% of that was fermentable, the rest is providing bulk, right? But that's 30 grams of fermentable fiber out of something like that. Now, the numbers I know can be debatable, but I tend to think of that and think that, well, maybe we are getting, that's a argument, maybe not so strong one, but that we're getting back towards how, the gut microbiota community evolved, what it was evolving on. Well, it was evolving on at least more fiber, I think, than we consume today. I would think, anyway.
Well, I totally agree that we need more liberal arts and history and bringing that information, because so often in nutrition, we get kind of hung up on a number and we beat it to death rather than saying, what's the big picture here? So obviously, I believe fiber improves health. So I definitely want to get us to eating more fiber. But rather than telling people there's only one way to get there, I think there's a lot of ways to get there.
I do think that this question really relates to the fact that fiber is I think, currently the only essential nutrient for which it was defined as essential based on something other than a well-established deficiency symptom. So it really does get to the question of maybe we are biohacking and we're saying, how do we get to more optimal health and define fiber as essential that way? So I thought that was really interesting. So one other question related to this is, can we talk a little bit more about fiber from different sources? Like, what are the health benefits of grains as compared to some of the other sources like pulses, or even getting into more of the isolated, extracted, and synthesized, the gums and refined fibers? Is there anything to say about kind of grains and compared to pulses, compared to these others?
I could talk about it, Barbara, from the epi side. So when you do an epidemiology look, we have most of our fiber does come from grains in the US for sure. And not that much comes from fruit, not that much comes from vegetable, and very little comes from pulse, very little comes from nuts. So when you're trying to get a signal and say, okay, of these fibers in these large prospective studies, which are the most likely to have some kind of effect on a health outcome that we've talked about, or a reduced risk of disease, it's really hard to get after that. And so I think, this is I go back and read some of the reviews we did in fruits and vegetables as a category. And this is, when you guys are talking about dietary patterns, we default to dietary patterns as a good way to give it information. But when we start saying, what's the data that any specific fruit or vegetable has a health benefit, we don't have studies to look at that because we're always eating this variety of diets. So I think that's what's hard for trying to isolate, okay, which of these different fibers are going to have that most signal in a study, and is it worth doing a study? If I'm the carrot producer, should I do a study? It really isn't, I don't think, to show that I can move the needle, because I'm already in an attacked and intrinsic fiber. And I think that was one of the reasons with the definition is, let's give real plant foods a pass. They don't have to do these studies to prove they have a physiological benefit in humans.
Anyone else want to comment?
Yeah, I can just add a little bit on there too. As far as the isolated and synthetic, one of the tools that I've also found really helpful, would be certainly the fiber database that Karen, Nicola talked about. The FDA has their evidence summaries where, when they were making the decision on the health benefits for each of those individual fibers, what were the doses, what were the specific health benefits, and then as Joanne alluded to, there's been some really nice epidemiological studies the Lancet put out. I'm trying to remember the first author just a couple years ago about reducing cardiovascular disease risk. But certainly, with the only thing that I would still say there is some interest in doing the studies, even if you are a whole food, if you have a fiber involved and have an opportunity for gut health, because people really are interested in gut health. Everyone, it's one of, like, gut talk is one of the most used hashtags on TikTok, for example. And doing those, are certain nuts going to help support gut health, or are certain fibers incorporated within whole grains, if you're blending those together, or a sourdough bread, those types of things. I think there is interest from a public perspective of, if there could be a gut health there. Again, those studies are going to be expensive to do, so it's ultimately going to depend on kind of, if these food boards are interested in it, or if a food company is interested in it. But from a scientific perspective, especially the food matrix and these individual foods and how complicated they are, that is something that I'm super interested in. And I think I'm excited that we're continuing to learn in that area.
I'd just add one quick thing, Barbara, is that like when we take, insoluble, like cereal cell wall fibers and solubilize, that's mostly arabinoxylan. There's some cellulose there, but the arabinoxylan, out of the matrix into the soluble form, it promotes a different group of bacteria, large group of bacteria. Really, the gram-negative Prevotella bacteroides really benefit, and they go to town on those soluble forms, while the insoluble matrix, if it's a kind of cereal bran that bacteria can ferment fairly well, then that promotes firmicutes, really that Clostridial butyrigenic group of bacteria benefit from that. So certainly different, I'm not making any big generalization, all soluble fibers do that and insoluble do that, but that's an example that certainly the form of the fiber and from the food source too will create different, support for different bacterial groups, put it that way.
Yeah. Hannah, I wanted to come back to you really quickly on just, can you give us a quick update on some of the new definitions of how they're thinking about prebiotics as part of?
Certainly. So yeah, Paula did a great job introducing that topic. And because again, there's so much interest in the microbiota and gut health, I did want to also be sure to mention to the group, because one of our goals is to make sure we know about tools. ISAP, the International Scientific Association for Probiotics and Prebiotics, puts out definitions for some of these different terms that have relevance for fiber, and one of those would be prebiotics. So in 2017, Glenn Gibson was involved in helping to update the prebiotic term, so that can be a great resource that individuals could use in addition to the paper that Paula included. And then also in this regard, synbiotics, which I was involved on the panel of scientists that helped update that term along with Glenn Gibson and many others. But that one, since a synbiotic also includes prebiotics and then substrates that can be utilized by the microbiota, for those terms and those papers published in Nature Gastroenterology Hepatology Reviews from 2017 through I think 2022 can also be great resources for individuals thinking about probiotics, prebiotics, synbiotics, postbiotics, all of these different otics that get confusing but have relevance for gut health. And some of them are fiber, some of them are not. And then, because I'm even thinking about, we didn't get into human milk oligosaccharides, for example, but I'm sure there are people in the audience that may have interest in those, and those could fit in the prebiotic category, for example.
And translating that for labeling, fiber isn't labeled as prebiotic or not. It's just labeled fiber, maybe soluble or insoluble, but so you're on your own if you're going to try to describe your fiber as prebiotic, I guess.
Yeah, and Paula can talk a lot more about that and how that's regulated, because the scientists are those ISAP panels, and there are other definitions, but it's a group of scientists that are putting together those particular definitions: prebiotics, probiotics, symbiotics. But then they do have considerations in those papers for regulators and consumers. But the regulation is out of my wheelhouse and understanding, the ins and outs of that.
Paula, you're on mute.
I mean, prebiotics will never be in the nutrition facts label, but because there are certain nutrients that must be in there, and then nutrients of concern. Fiber is one of the mandatory nutrients. It was called something else when the law came out, but that's the opportunity, because that is it's related to a function. So it's perfectly fine to describe that prebiotic activity as like a structure function claim. You'll see many structure function claims that are just single words: immunity, whatever. And so prebiotic or the examples I gave would be perfectly fine, provided that, it's substantiated for the fibers that are in that product.
Okay. All right. I have one here for Kara. In terms of somebody who's interested in looking at various doses tested by fiber type or by outcome, to what extent can they get those papers identified through the database, both by dose and also the health outcomes you listed weren't specifically tolerance outcomes? How might a person use a tool if they were interested in the tolerance outcomes?
Yeah, so with respect to the tolerance outcomes, I think I would suggest if that was your main outcome, doing some additional searches around that. The database probably does capture some of those outcomes within the context of other papers and outcomes searched for, but that wasn't specifically targeted in the search. So I'm sure that there are many other papers out there that we wouldn't have in the database just because the search specifically targets those 10 outcomes that are shown. And it does capture other outcomes in papers with those 10 outcomes, but ultimately it goes down to those 10 outcomes. And with respect to dose, the database does capture dose, although that is one of the more challenging fields to capture just because depending on the paper, as I'm sure you all know from reading the literature, it's not always clear in terms of how the authors present the dose. Is it the dose for the fiber? Is it the dose for the food with the fiber? So we've done our best to try to either take from the paper or calculate to put in the database the dose from the actual fiber that is described, you know, as the fiber type in the database. But if you were really interested in getting into like the details of the doses, that's where I think it would be great to use the database to identify the papers of the fiber types and or outcomes you're interested in, and then use the database to go from there and then really go into those papers and kind of target, you know, some more details on the dose.
Okay. We've had a question here about mushrooms. Mushrooms got brought up, I think, during Bruce's your talk, but others might have some comments on it too. What's going on with mushrooms? Can you give us some ideas of what's beneficial? And are there some ingredients that people could use as well that would be worthwhile formulating for a health outcome?
I can start with a few words.
Ken?
Oh, go ahead, Joanne.
Yeah, it's just we had done a mushroom study a few years back. So mushrooms are pretty interesting because they're not, they don't fit anywhere. They're not whole grains, they're not fruits, they're not vegetables, they're fungi. So in our results too, the composition of mushrooms pretty interesting. They have fiber, but they also have some sugar alcohols and other compounds. And they did have an effect on gut health in some of the measures we looked at in our mushrooms feeding study, where whenever you do whole food studies, it's kind of frustrating because you need to give enough to have a signal. So we fed a lot of mushrooms in that study, but we did get some interesting effects. So I think it's a great area to expand into. And what part of the mushrooms would be most likely to change the gut microbiota, I'm not sure, but some of the fibers and some of the sugar alcohols would be good candidates.
Yeah, I think I know that paper, and it's I really like that paper, Joanne. I think you really said it. Only that to say that the types of fibers differ structurally. Some, you know, there's a lot of beta glucans, but it's fungal beta glucans. It's a different kind of beta glucan, and we did an in vitro study. We never published that, but on a number of different types of mushrooms. And it's, you know, that one I showed you had that particular effect and a butyrogenic effect in vitro, but they don't all. So yeah, more work needs to be done to understand that better.
Yeah.
You opened the beta glucan can of worms there. Did you want to just quickly summarize beta glucans, health benefits, sources, maybe just kind of the top line for anyone who's not familiar with beta glucans, benefits or sources?
Yeah, I think the beta glucans are, they're generally associated with viscous foods, right? For like oat beta glucan or barley beta glucan. But these fungal beta glucans are different in structure. And a lot of them are insoluble, some are soluble. And as Joanne said, the research has not really gotten into that level of structure and function. But they're quite different from the cereal beta glucans that we most of the time, when people hear beta glucans, they think of cereal beta glucans.
And if I remember right, there's some link to immune response. So for example, if you take beta glucans, you get an improved response to an immunization, vaccination. Is that right? So there's some immune, is there also cancer?
Right, there's studies on that.
URTIs. Mm-hmm.
Those are fungal beta glucans mostly, to my knowledge.
Yeah.
Sometimes I'm slow here because I'm actually responding to some individual questions as we go here. So I think we're getting towards the end on questions, and I want to pull up one last question that I think might be a nice ending
Hey,
one.
Barbara, I just wanted to make a quick plug because we were talking about, a particular food and how those beta glucans vary between the greens and the mushrooms. And several of the speakers mentioned how important it is for us to continue to expand the fiber databases so we even understand what fibers there are in foods so that we can link those back to particular health outcomes. And so again, just investing in those even within the whole food. So for example, one of my grad students, Maria Sanabria, just did an in-depth analysis of avocados and what the fibers are within them because and it's just such, so that we can begin to tease back what may be underlying some of those health benefits, because as Bruce talked about really nicely, different microbes are involved in breaking down different fibers and then soliciting different health outcomes. So kind of one of the take homes that I get from the conversation we've just been having here is, again, fiber is an umbrella term. Different fibers have different health benefits, and, moving these into the food system is really important. And so understanding those better is, I think, a goal for all of us in this room.
Yeah, it reminds me of some of the work Colin K is doing and stuff on the metabolomics, where you're actually measuring the metabolites in the body and then backing out of it and figuring out what food sources might have delivered those metabolites that are associated with health outcomes. Really fascinating work. So we're going to do two last things. First, I have a question posted, and we'll get you to weigh in on that, those of you who want to. And while that's happening, I ask each of you to think of your last kind of 30-second headline that you'd like as the most important point that you would like members or participants of this webinar to take away. So first, response to this question. So here's a thought. You have a food technologist who's looking at FDA's proposed healthy definition that focuses on servings of fruits or vegetables. And they're thinking, gosh, if I meet those proposed guidelines with my fruit or vegetables, does that mean all of those, that all of the fiber that's in those ingredients that qualify, are they going to count as fiber automatically in my facts label? Is that kind of an obvious yes, or is it a maybe, or is it a who knows?
It's an obvious yes, in my opinion.
Oh,
So Paula,
No,
this is what we want, is difference of opinion. What do you think, Paula?
no, wait a minute. I want to understand why Joanne said yes.
Why would we, no, I don't want to get into the healthy claim. You can get into that, Paula. I want to say
we don't, yeah, I'm
there's
part of this new healthy stuff.
I'm going to put it on my nutrition facts panel, and I can be happy with that. That will not
You're
hurt.
hopeful that it's a yes.
It is a yes.
Okay, you're hopeful it's a yes. Okay, Paula, what's the
it's a yes.
details of the reality here?
I would just say generically that unless there's explanation in this new healthy regulation about this, regulations are separate on their own.
Got it. So, okay. So to me, that's a nice headline, which is that you have to look at each one separately. So once you've met the criteria for the fruit or vegetable counting as a serving, then you layer on top, does that now count as an intrinsic intact fiber in order to automatically count it? And if it isn't, how are you going to deal with the remains, right?
Right. The nutrition facts panel is in 21 CFR 101.9 and nowhere else.
Got it. Fascinating. Okay, I like that. All right, so we are going to start from the top in the order that you spoke. Your top line, what is the most important thing you want people to take away in 1 or 2 sentences? Joanne, you're up.
I just think that fiber crosses all these different categories, and this is a great example of everybody working together. So it's nice. I've gotten lots of emails from my friends out there, and just how helpful this is. So getting information of how to get fiber on foods beyond nutrition, getting it on the food science radar, really appreciate the opportunity to participate.
I think I heard you say, don't be pejorative about where it comes from, get it from everywhere. Anywhere you can.
Mushrooms work for me too.
Beta 1316.
Even though they're not a plant or they're not a nothing, it all works. It all works.
It's in the dietary guidelines.
All right, Paula.
I'm just glad to see that this new definition that FDA has adopted is expanding to other countries and jurisdictions. I know it's been a pain to many companies to have to go through this and to worry, oh, is our fiber going to be meet the definition or not? But I think it was a lot of work, but I think it was the right thing to do. And because it's all about health benefits when it comes to fiber. Someone says we don't have deficiency symptoms, so it's about optimal health. And so you need to provide that. And it's good to know when you add these ingredients, what are those health benefits? I know it's limited in how much you can add to a food, but it's been a lot of work, but I think it turned out to be a good thing.
I think we heard every little bit counts, so get it in there.
Yeah.
Bruce.
Well, I would say that mixtures of fibers, and I would include soluble and insoluble fibers, would tend to lead to a supportive, food for the gut microbiota community. And I think that overall that's probably beneficial to gut health and total body health.
And Hannah, your closing.
Yeah, I think barely anyone is eating enough fiber, right? Less than 10%. And I'm excited to see people from different sectors interested in how can we incorporate fibers that will be healthful and palatable and stable on the shelf. So thinking and working together is really important, and characterizing those in a way we can understand how are they having these health effects, be it the microbiota or other mechanisms. So those are some of the gaps. And then certainly the headliner from my presentation is please don't forget tolerance, right? I included some tools, the perspective paper that has been published on those are open access. Please use those tools. And then certainly another plug, for the Nicola and Kara and the great work they've done on their tool as well, because we use that to build on our the two papers that I presented as well.
Yeah, putting yours and Bruce's together, you could really do some fiber mixtures in order to minimize the tolerance and maximize the efficacy, right? All right, with that, I'm going to thank first and foremost IFT for partnering with IFNS, for our experts on the call, many of whom were very involved in planning, not just presenting, to the Carbohydrate Committee at IFNS specifically. And I also wanted to thank you as participants. It was a long webinar, but we will also provide to you through IFT. You'll get a link to this webinar in case there's sections you missed or want to re-look at or share. And you also can send a link directly to Wendelin at ifns.org if you would like to have it through the YouTube, or if you have other questions, for example, about joining or working with IFNS in any way. With that, thank you and have a great rest of your day.
Yes, and also thank you to the Carbohydrate Division at IFT for collaborating on this event with IFNS. If you are a student and you are interested in fiber, they do have a student hackathon coming up, and I will drop the link in the chat, and you should be receiving a video copy from me shortly. Thank you to everyone.
Thank you, Sydney, for keeping us going here today.
Yes, of course.
Okay. All right. Thanks.
Thank
Bye.
you. Have a nice day. This webinar will now close.